Welcome back to Sleep Nova. Sit back, relax, and enjoy the show. The quiet death of a sun-like star. It begins with a single light in the darkness. A star, solitary and brilliant, burns in the void. For ages untold, it has been a beacon, a steady, shining pinprick against the infinite night. Its light has traveled across the cosmos, a silent tale of its life. But now, something changes. The star's shine falters, ever so slightly. Its once unwavering glow begins to dim and flicker like a candle reaching the end of its wick. In this moment, we witness the opening lines of a final act, the beginning of a star's dying. Even the stars are mortal. For ancient peoples gazing up, the very idea of a star dying would have seemed impossible. The stars were regarded as eternal campfires of the gods or the fixed points of the firmament. If ever a new star appeared or an old one disappeared, as happened with rare supernovae recorded in history, they were seen as divine omens, not natural events. Only in modern times have we come to understand that these dramatic changes are the logical, even inevitable progression of a star's life. A star's birth, life, and death are part of the cosmos's story, not the caprice of deities. The star swells imperceptibly at first, then noticeably. Once contained and stable, it now grows bloated and luminous, turning a deeper shade of amber, then red. Its outer layers, no longer tightly bound, drift outward into space. If there were eyes watching from a nearby world, the star's transformation would paint the sky in hues of scarlet twilight, even at midnight. This ancient sun is becoming a red giant, a star near death, casting off the vestiges of its youth. Imagine standing on that distant world. The star that once gently rose and set now looms huge and ominous, filling a quarter of the sky. The air heats and the ground cracks under a perpetual red dusk. Oceans, if they exist, begin to boil away as the star's dying light intensifies. The planet's sky is on fire. Day and night, a sullen ruby glow suffuses the heavens. For even when the star is below the horizon, its scattered light paints the atmosphere blood red. Any moons or nearby planets that once circled safely now face an inferno. The star's swollen photosphere might even reach out and consume its innermost planets entirely, erasing them in a final act of cosmic devouring. The once life-giving star has become a cosmic furnace, heralding doom. It is a breathtaking and terrifying spectacle, beautiful in its grandeur and heartbreaking in its finality. Why must even stars die? To answer this, we look into the heart of the star. For eons, in the core of that star, a mighty engine has burned. The star's purpose throughout its long life was to fuse the lightest elements into heavier ones, to take the simplest gas of the universe and forge it into something new. In its core, hydrogen atoms were pressed and squeezed so tightly that they merged into helium, releasing a tremendous burst of energy that made the star shine. This fusion is the star's heartbeat, a constant thrum pushing outward against gravity's incessant pull inward. Every second, countless atoms join together, and with each union, a packet of energy is born and fights its way from the core to the surface, eventually escaping into space as starlight. It is as if the star stands in a delicate balance, a perpetual tug of war, gravity drawing it inward, energy from fusion pushing outward. For a time that seems infinite to us, this cosmic heart pumps steadily, and the star remains in glorious equilibrium, neither collapsing under its own weight nor dissipating into the void. As long as the fusion fire burns in its core, the star lives on, an incandescent beacon of stability. But nothing in the universe is truly eternal. The star's fuel is finite, and one quiet day in the deep future, the fusion fire begins to falter. The hydrogen that sustained it for so long becomes scarce in the core. Like a lamp running out of oil, the light begins to change. With less outward push from the diminishing core fire, gravity tightens its grip. The core, no longer able to support the weight of the star's layers, starts to shrink. And as it contracts, something remarkable happens. It grows hotter, far hotter than it ever was during its placid youth. In that rising heat, a new kind of fire is kindled. The helium ashes, left from millions of years of hydrogen burning, suddenly become fuel themselves. In a furious flash, 3 helium nuclei slam together to fuse into carbon. The star's heart, which was faltering, gets a new surge of energy. It's like a second wind in old age, sudden, fierce, but short-lived. The core's collapse is halted by this burst of helium fusion. Bolstered from within, the star swells dramatically and becomes a red giant. Now our once small star is a swollen titan. Its outer layers have expanded hundreds of times over, cooling and glowing a rich, coppery red. To any distant observer, this aging star has become an enormous beacon, far larger and more luminous than it was in its youth. Yet its brilliance is deceiving. It is the brilliance of old age, not of vitality. Inside, the star is dying. The helium fuel at its core will not last long. Compared to the billions of years of its hydrogen-burning prime, the helium burns in a relative instant, in only a few % of that time. The star is living on borrowed time, using up its last reserves in a final prodigious blaze. In the star's final breaths, it becomes unstable. It pulsates, expanding and contracting, as if it were a gigantic cosmic lung drawing ragged breaths. Each expansion and contraction is vast and slow, taking perhaps years or decades, but in the life of a star, it is a frantic oscillation. With each pulse, the star sheds some of its outer gas into space, like a series of sighs, creating shells of material that drift away into the surrounding darkness. Between pulses, the star's hot core shines through more clearly, its intense radiation pushing on the remaining layers. A stellar wind, a stream of particles from the star's surface, begins to blow the star's atmosphere outward. The dying star is both lamenting and creating with these breaths, for the gas it expels is rich with elements forged over its lifetime. Carbon formed in the star's core now flows outward in gentle currents. The star is painting its own epitaph in the skies around it, layer by layer. At last, the star can no longer hold onto its outer layers at all. One final large pulse or wind sweeps them completely into space. The great bloated red giant effectively sloughs off its entire outer envelope. All that remains behind is the hot, naked core of the star, now exposed to the cosmic vacuum. For a brief moment in cosmic time, that core, small as it may be, perhaps only the size of Earth or smaller, shines fiercely. It is incredibly hot, having been the furnace at the star's center, and now with no overlying layers to obscure it, it radiates intense ultraviolet light into the space around it. The formerly expelled outer layers, drifting nearby, suddenly find themselves bathed in this energetic glow. They begin to fluoresce, lit up from within like a neon sign. A shell of multicolored gas materializes around the star's core, expanding outward. This is a planetary nebula, the quiet, haunting aftermath of a star's gentle death. Under the gaze of telescopes, it appears as a delicate bubble or ring of glowing gas, expanding gradually into interstellar space. To an eye peering from afar, it might resemble a ghostly flower blooming in the dark garden of the galaxy, a final blossom from the star that was. The colors of this nebula can be vivid, subtle greens and blues from oxygen atoms, reds from hydrogen, all mixing into an ethereal pastel tapestry. The shapes are surprisingly intricate. Some nebulae form perfect spheres or rings, while others are sculpted into hourglass forms or butterfly-like wings by the star's magnetic fields, or perhaps by the gravity of unseen companion stars. At the center of this luminous cloud floats the small stellar core, now called a white dwarf. It is a stellar corpse, extremely hot but fading, shining only with leftover thermal energy. A white dwarf is usually no larger than a planet, yet contains nearly the mass of the original star. It's incredibly dense. The star's mass is now crushed into a sphere perhaps the size of Earth. The matter inside is in a strange, degenerate state. Atoms pressed so close that electrons are squeezed free of their orbits. No fusion fires burn in this core anymore. It glows like an ember taken from a fire, brilliant at first, but destined to dim over the eons as it cools. Such is the quiet death of an ordinary star. A star like this one, perhaps like our own sun someday, does not end in violence, but in a peaceful casting off, a cosmic setting of the stage. Its final act is to illuminate the gases of its own shed self, creating a hauntingly beautiful nebula that will linger for only a few millennia before dispersing into the surroundings. That glowing shell is a brief memorial, a glowing epitaph written in space, commemorating the star's existence. In time, even that nebula will fade, its atoms drifting away to mix with the interstellar medium. In dying, the star returns its substance to the galaxy. The elements it formed, carbon and nitrogen from its later fusion, and even new molecules forged in the cooling breath of its final winds, are cast back into the cosmic reservoir. The star's death is an ending, but also a bequeathing. Its carbon will become the seed of new organic molecules. Its dust may gather into future planets. In this gentle goodbye, the star enriches the universe with the products of a lifetime. Yet not every white dwarf rests quietly forever. If a small star's corpse orbits in a close binary system with another star, it may later find a way to die a second, more violent death. As a white dwarf steals gas from its companion, it grows heavier until reaching a critical weight. At that point, its carbon heart can ignite in one furious wave of fusion, consuming the star from within. In a matter of seconds, the white dwarf is blown to bits, a titanic thermonuclear explosion. This is a type of supernova as well, often called type Ia by astronomers, and it can rival the brightness of a core collapse supernova. In this scenario, the entire star is destroyed, with no neutron star left behind, just an expanding cloud of debris rich in newly forged elements like iron and nickel. Even a star that lived quietly can thus end in sudden violence if given this final push. Such explosions are another way the galaxy is seeded with the heavy elements that will become part of new cosmic generations. The explosive death of massive stars. Now, consider a star far more massive, a true stellar giant many times heavier than our Sun. Such a star, born with tens of times the Sun's mass, lives a very different life and meets a far more dramatic end. Where a smaller star like the Sun quietly sloughs off its outer layers, a massive star lives and dies in raging fire. It is a brilliant blue-white beacon during its life, far hotter and more luminous than an average star. It burns its fuel at a prodigious rate, living fast and dying young, as one might say. For millions of years, a mere blink compared to the billions our Sun will enjoy. This massive star fuses the lightest elements in its core at a feverish pace. Its core temperatures and pressures soar much higher than those in smaller stars, and the chain of nuclear fusion proceeds beyond just hydrogen to helium. Once helium is exhausted, the core, under crushing gravity, contracts and heats again, and new fusion reactions ignite in succession. Carbon burns into neon, neon to oxygen, oxygen to silicon, step by step forging heavier and heavier nuclei. Each new fuel is consumed faster than the last, as if the star knows its time is short and rushes through one element after another. Deep in the heart of this giant, a ball of iron begins to form, and with it, the star's fate is sealed. Iron is a strange endpoint for the star's nuclear alchemy. Unlike the lighter elements, Fusing iron does not release energy. Instead, it greedily absorbs energy. All the star's prior steps of fusion had been exothermic, releasing the energy that held the star up. But when enough iron accumulates in the core, further fusion becomes futile. The stellar engine that has thrummed for millions of years suddenly sputters and stalls as it tries to fuse iron. In a star so huge, this failure is catastrophic. Gravity, which has been held at bay for so long by the outward pressure of fusion, now has no effective counterforce in the core. There comes an instant, a final unforgiving moment, when the iron core can no longer support the enormous weight of the star's outer layers. In the blink of an eye, the core collapses. A star that dwarfs our sun in size implodes in less than a second. The iron atoms in the core, under the extreme pressure, are crushed together. Protons and electrons merge into neutrons in a burst of particle transformations. The core, which might have been the size of Earth, shrinks to a sphere only a few tens of kilometers across and is as dense as an atomic nucleus. The collapse releases an almost unimaginable amount of gravitational energy, heating the core to billions of degrees. A flood of neutrinos, nearly massless, ghostly particles born of nuclear reactions, erupts from the core and flies outward. In fact, so much energy is carried by these neutrinos that for a brief moment, they outshine the star's luminous output by a factor of hundreds. It is as if the star's soul is escaping in the form of these ghost particles, rushing out in all directions. This is the opening of the most violent event in the star's life. The core collapse triggers a supernova explosion. The infalling outer layers of the star, which were rushing inward following the collapsing core, slam into the now rock-hard wall of densely packed neutrons that the core has become. In that violent collision, the infalling matter rebounds. A powerful shockwave forms and begins to propagate outward. The shock, energized by the deluge of neutrinos streaming from the core, plows through the star's layers, tearing them apart. Within hours, the shock reaches the star's surface and blasts the star apart in one titanic explosion. The star that once shone steadily is now gone, and in its place is a swelling fireball of stellar debris. For a brief time, this single dying star outshines its entire galaxy. What was once a distant point of light now becomes a beacon so brilliant that it can be seen across millions of light years. If there were civilizations looking up from planets in that galaxy, they would see a searing new star light up the sky with ferocious intensity, perhaps casting shadows at night and outshining their moon. On Earth, even though such explosions are rare in our galaxy, humans have recorded a few over the centuries. Ancient skywatchers around the world noted guest stars suddenly appearing in the sky, bright enough to be seen in daylight for weeks. They were witnessing supernovae, though they did not know it, the death flashes of giant stars. In modern times, astronomers have captured many such events in other galaxies. In the late 20th century, they witnessed a supernova in a nearby dwarf galaxy, the brightest seen in almost 400 years. For weeks, it glared in the southern sky, a stark reminder that even the heavens can erupt without warning. A supernova pours out not just visible light, but every form of electromagnetic radiation, from searing X-rays and gamma rays to long, lazy radio waves. It also launches matter at incredible speeds, a hurricane of gas and dust racing outward. The energy of a supernova defies easy comprehension. In those few seconds of collapse and rebound, the star releases more energy than it did in its entire millions of years of normal life. People sometimes say it's like a billion suns lighting up at once. If a supernova were to occur within a few dozen light years of Earth, it could outshine our moon and potentially disrupt the biosphere with its high-energy radiation. Yet, from a safer distance, it would be one of the most glorious sights in the universe. A cosmic firestorm, the sudden blossoming and slow fading of a star's last light. And amidst this destruction, there is creation. In the heart of the supernova explosion, the chaos and heat forge new atomic nuclei that the star never could while it lived. The shockwave's extreme conditions allow atoms to slam together and capture neutrons rapidly. Elements heavier than iron, which the star could not produce in its normal life, are manufactured in these brief moments of fury. Gold, silver, platinum, iodine, uranium. The universe's precious metals and rare elements are born in the crucible of the exploding star. Before stars, the universe held only the lightest elements: hydrogen, helium, and a dash of lithium from the Big Bang. All the rest, carbon and oxygen, iron and gold and beyond, were forged in stellar furnaces and in these titanic explosions. In this way, almost every element heavier than helium is a gift from stellar lives and deaths. Atomic nuclei absorb neutrons in rapid succession. Later, those neutrons decay into protons, transmuting the elements into heavier ones on the periodic table. The star, in dying, becomes an alchemist on a cosmic scale. The brilliant glow of the supernova begins to be tinged with the spectral signatures of these freshly minted elements. When the debris eventually cools enough, these atoms will combine into dust grains, floating through space, awaiting incorporation into future worlds. Thus, the star's violent death is also a moment of genesis, the birth of new materials that will enrich the galaxy. What remains after such a cataclysm? As the glare of the supernova fades over weeks and months, and the expanding cloud of ejected gas thins out, we peer into the aftermath to find a newborn object at the center. If the original star was massive but not too extreme, perhaps up to 20 times the Sun's mass, the core that's left behind is a neutron star. This neutron star is a tiny, ultra-dense sphere, only about as wide as a city is long, yet containing more mass than the entire Sun. It is essentially a giant atomic nucleus, a ball of neutrons packed shoulder to shoulder. In fact, the first supernova explosion observed by ancient skywatchers, a guest star in the 11th century, whose remnants form a beautiful nebula visible today, left behind a neutron star that still sits at the center of the expanding cloud, spinning and flashing. For a neutron star is not a quiet thing, at least not at first. Neutron stars, pulsars, and magnetars. Often, the newborn neutron star is incredibly hot and endowed with a rapid spin inherited from the core of the star that collapsed. Conservation of angular momentum, the same principle that makes an ice skater spin faster when they pull in their arms, means that a core that was spinning moderately will whirl madly as it shrinks. A neutron star can rotate dozens or hundreds of times each second. Along with this spin, it carries an immensely strong magnetic field, intensified by collapse, just as the spin was. The result is one of the universe's most astonishing phenomena: a pulsar. Bright hotspots form at the neutron star's magnetic poles, where intense beams of radiation shoot outward. As the neutron star rotates, these beams sweep around like the lighthouse beams on a dark shore. If Earth lies in the path of those beams, we see the neutron star blinking on and off regularly. A cosmic lighthouse marking the location of the lost star. When the first pulsar was discovered in the 1960s, its signal was so regular, a pulse every 1.3 seconds, that the astronomers half-jokingly named it LGM-1 for Little Green Men, thinking it might be an artificial beacon. Soon they found more and realized these were not alien signals, but the heartbeats of dead stars. These neutron stars are among the strangest objects in existence. A teaspoon of neutron star material on Earth would outweigh a mountain. The gravity at its surface is so immense that if you dropped a marshmallow from a few feet above, it would hit the surface with the energy of a nuclear bomb. The neutron star's magnetic field is trillions of times stronger than Earth's. In some neutron stars, called magnetars, The field is so ferocious that it can distort the very structure of atoms and unleash bursts of high-energy radiation. Magnetars occasionally experience starquakes as their rigid crusts crack under magnetic stress, releasing tremendous flares of gamma rays. In 2004, a magnetar on the other side of our galaxy erupted, and even from tens of thousands of light years away, it briefly ionized Earth's upper atmosphere. These exotic stellar remnants may be small, but they can be more energetic in certain moments than almost anything else in the cosmos. The neutron star gradually cools and slows its spin over many millennia, especially if it has no companion feeding it fresh energy. Its lighthouse beams dim. In the far future, that neutron star may become practically invisible, a cold, dark sphere of neutron matter, drifting silently through the galaxy like a spent coal from a great fire. But at least initially, in the aftermath of the supernova, it is very much an active presence, a cinder with a fiery glow. In some supernova remnants, the neutron star's wind of high-energy particles continues to energize the ejected gas long after the explosion, making the nebula glow in fantastical shapes and colors. If the original star was even more massive, say on the order of 20, 30 or more times the mass of our Sun, then even the neutron star outcome is denied. In these cases, the core that tries to form a neutron star might be so heavy, more than a few times the Sun's mass, that not even the degenerate pressure of neutrons can hold it up against gravity. Nothing in nature can withstand the gravitational crush of such a massive core. Black holes, the ultimate collapse. In that case, the core collapses further, past even the neutron star stage, and vanishes from view entirely. The star's core becomes a black hole, an object so dense and with gravity so strong that within a certain boundary, not even light can escape its pull. Around this collapsed point lies the event horizon, the spherical surface marking the point of no return. Space and time themselves are warped around this region. If we could watch the dying massive star's final moment of collapse to a black hole from a safe distance, we would never actually see it disappear. Instead, we'd see the star's image freeze and dim as the last light it emits gets stretched to redder and redder wavelengths, time appearing to almost stop at the brink of the event horizon. In reality, the star's core continues to collapse beyond our view, but the information about it is forever hidden behind that horizon. The newly formed black hole now contains the mass of several suns in a sphere only a few kilometers wide. Its gravity is a pit from which nothing escapes. A black hole is the most extreme remnant of a star. The core of the star has been compressed beyond any known limit. At the center lies a singularity, a point of almost infinite density, shrouded by the event horizon. But contrary to popular myth, a black hole is not a cosmic vacuum cleaner indiscriminately devouring everything in sight. If our Sun could be instantly replaced with a black hole of the same mass, Earth's orbit would remain unchanged, though our world would freeze without sunlight. One has to get very close to a black hole, inside the Schwarzschild radius, to be irretrievably pulled in. Sometimes, the demise of a very massive star can create an even more spectacular signal. If the star was rapidly spinning and had strong magnetic fields, the collapse into a black hole can produce jets of material shooting outward from the poles at nearly the speed of light. These jets drill through the collapsing star and burst out into space as intense beams of gamma rays. We call this event a long gamma ray burst. For a few seconds, a gamma ray burst from a collapsing star can be the brightest electromagnetic event in the observable universe, detectable across billions of light years. It's a dying star's last scream, a focused, deadly burst of energy indicating the birth of a black hole. Satellites have recorded many gamma ray bursts, and in some cases have spotted the faint afterglow from the exploding star's remains, confirming that they were indeed massive stellar explosions, likely linked to black hole formation. In rare cases, a massive star might even collapse directly into a black hole with no supernova explosion to herald it. The star's core simply implodes and keeps imploding as the infalling outer layers follow it past the event horizon. From the outside, one might witness the star suddenly dimming and disappearing, as if a trap door opened beneath it. For a brief moment there could be a burst of neutrinos or a slight gamma-ray flash, but no brilliant supernova blast. Such an event is sometimes termed a failed supernova. In recent years, astronomers identified a candidate, a massive star in a nearby galaxy that brightened slightly, then faded away to nothing, leaving no trace. It seems that nature can be both extravagant and miserly with its farewells. Some stars go out in a blaze of glory, while others quietly wink out, leaving darkness and a newfound black hole where once a star shone. As many as a third of the most massive stars may die in this undramatic way, simply collapsing into the void. These are truly the most secretive of stellar deaths. Aftermath, ghosts and rebirth. Whether through a titanic supernova or a quiet collapse, the end of a massive star leaves space forever changed. The debris cast off from the explosion races outward at millions of kilometers per hour, a shockwave plowing into the surrounding interstellar gas. Over years and decades, observers with telescopes can see this shell of debris expanding, a ring of sorrow growing larger but fainter as it dissipates its energy into space. This glowing remnant, enriched with all those new heavy elements, mingles with the interstellar medium, the tenuous gas between stars. In time, that gas may become the raw material for new stars and planets. A supernova's remnants are like the scattered ashes from which new life will emerge, glittering, multicolored nebulae cooling into the darkness. Sometimes, amid those remnants, the core that was left behind makes its presence known. In one famous supernova remnant, a pulsar spins madly, lighting up the surrounding cloud with pulses of energy and winds of particles that cause the gas to glow. In other cases, if the remnant core was a black hole, we might see high-energy X-rays or gamma rays if the black hole is consuming material around it. Often, however, the black hole simply is, unseen, its gravitational field the only testament to a star that once shone. Now our journey takes an even stranger turn. The death of one star, spectacular as it is, can give rise to an even more dramatic event under the right circumstances. Consider a binary star system, two stars orbiting one another in a celestial dance. If both stars are massive enough, both might eventually become supernovae in their time, leaving behind two neutron stars orbiting their common center. Over millions of years, their gravitational dance continues, but with each orbit, they draw imperceptibly closer. Their spiraling movement generates gravitational waves, ripples in the very fabric of spacetime, that carry energy away and bring the neutron stars ever nearer to collision. Kilonovae, cosmic collisions and gravitational waves. Finally, long after they were born, these two city-sized remnants meet their fate together. They collide and merge in a violent embrace. In that moment, a new kind of fire ignites. The merging of two neutron stars creates an event we call a kilonova, a cosmic flash that, while not as bright as a supernova, shines 1,000 times brighter than an ordinary nova. For a few days, the site of the merger glows with a blue then red light. It is an event both fierce and brief, a final fireworks display from the corpses of stars. The physics of this collision is extraordinary. When neutron stars merge, their incredibly dense matter gouges and shocks itself, forming exotic heavy elements in profusion. If supernovae are one forge for the heaviest elements, kilonovae are another, perhaps even more prolific for certain treasures. In the debris tossed out by the merging neutron stars, astronomers have detected signatures of gold and platinum being created in astonishing quantities. In mere seconds, more gold may be forged than in all the cores of stars over billions of years. The kilonova's glow is powered by the decay of these new, unstable heavy atoms as they release energy. Alongside the light of the kilonova, the merger rings the universe like a bell. Gravitational waves ripple outward from the collision, stretching and squeezing space-time itself. By the time these waves reach us, they are faint echoes, but with sensitive instruments, we have learned to listen for them. In recent history, humanity has detected such ripples, hearing the chirp of two neutron stars colliding in the depths of space. In tandem, telescopes caught the delicate afterglow of the kilonova, marking the first time we both saw and heard a cosmic event of this magnitude. In some neutron star collisions, the two merging stars might collapse into a black hole immediately after the merger, swallowing some of the heavy element-laden debris. In others, they might form an extremely massive neutron star that survives for a brief time. But either way, they leave a changed environment rich in freshly minted elements. These elements will drift through space, become part of gas clouds, and one day be incorporated into new worlds. It is awe-inspiring to realize that the gold in a ring on a person's finger likely came from such a merger of two long-dead stars, billions of years ago in our galaxy. The violence of that moment becomes the gentle gleam of metal we see and cherish, a direct connection between cosmic catastrophe and human ornament. Observing stellar death. Throughout all these scenarios, humanity has slowly learned to read the messages in the skies that reveal these processes. How do we know these tales of dying stars when no human has watched a single star go through its entire life cycle? The truth is, the universe has left clues for us, and with our ingenuity, we have learned to gather them across the light years. We piece together the story of stellar death from many different kinds of observations across many types of cosmic messengers. First and foremost, we see the light. Visible light from supernovae has been recorded by sky watchers for millennia. From the sudden appearance of guest stars noted in ancient chronicles to the careful telescopic monitoring of distant galaxies by modern astronomers who catch supernova flickering into brightness like cosmic fireflies. We have captured images of glowing planetary nebulae around dying sun-like stars, each a snapshot of a star's final sigh. We have seen the expanding shockwaves of supernova remnants, their tendrils growing over years in photographic time-lapse, confirming that they are indeed blasts in slow motion. But light is just one messenger. We have also learned to detect radio waves, which reveal phenomena invisible to our eyes. In the radio spectrum, pulsars announce themselves clearly. Their lighthouse beams become pulses of radio emission that our radio telescopes can pick up. The very discovery of neutron stars came from radio astronomy. To this day, radio observatories map the intricate structure of supernova remnants, picking up the radio glow of electrons spiraling in magnetic fields there. Through radio eyes, we have seen the remnants of star death stretching across vast swaths of sky, invisible in ordinary light. Then there are the neutrinos, those ghostly particles that rarely interact with matter. When a massive star's core collapses, an enormous number of neutrinos are released. In one famous supernova, underground detectors on Earth registered a sudden burst of neutrinos. A full few hours before the supernova's light became visible in the night sky. Those neutrinos had raced out from the collapsing core, heralding the death of the star before the light from the explosion could fight its way out. It was the first and only time so far that we directly detected such a neutrino burst, and it confirmed our theories about what happens inside a dying star's core. Now we wait eagerly for the next nearby supernova, knowing that neutrino detectors will ring like alarm bells, perhaps even allowing us to witness the core collapse in neutrino signals ahead of the light show. In recent years, we have opened our ears to the gravitational waves, adding a whole new sense to our astronomical repertoire. When massive objects like neutron stars or black holes collide, they send out ripples in space-time that travel across the universe. Detectors on Earth have picked up these tiny distortions as they pass by. Through gravitational waves, we heard the final moments of binary black holes merging, events completely dark to electromagnetic telescopes. We also heard, and then saw, a pair of neutron stars collide and light up a kilonova. Gravitational waves have allowed us to confirm directly that yes, black holes and neutron stars do merge exactly as long predicted, releasing energy not as a flash of light, but as a faint trembling of the cosmic fabric. It's as if we developed the sense of hearing after millennia of only seeing. Whole new phenomena have become perceptible. Each type of messenger, light, radio waves, neutrinos, gravitational waves, gives us a different insight into the death of stars. By combining them, an incredibly detailed and holistic picture emerges. For example, by studying a supernova's light alone, we learn about its energy and composition. By catching neutrinos from it, we peer directly into the core collapse physics. By listening for gravitational waves, we might witness the formation of the neutron star or black hole in real time. The universe has been gradually revealing its story through these multiple channels, and we have become adept at tuning in. Armed with this knowledge, we can turn our attention to the star that matters most to us, our Sun. The Sun is a fairly ordinary star, midway through its life, but one day it will undergo its own deathly transformation. It will not explode as a supernova. It lacks the mass for that ferocious end, but the Sun's demise will nonetheless be a dramatic and profound event, especially from the perspective of any living beings that might witness it. The fate of our Sun. In about 5 billion years, an unimaginable span to us, yet a fixed and finite countdown in cosmic terms, the Sun will exhaust the hydrogen fuel in its core. As it begins to run out of gas, the Sun's core will contract and heat up, and, just as we described for a smaller star's final stages, helium fusion will ignite. Our star will swell into a red giant. In those distant days, the Sun will expand to hundreds of times its current diameter. Mercury and Venus, the inner planets, will almost certainly be engulfed, devoured by the Sun's bloated fiery plasma. Earth's fate is less certain. Some calculations suggest it might just escape engulfment, spiraling outward a bit due to the Sun's mass loss. But even if it isn't swallowed whole, it will be scorched and sterilized. The oceans will boil off, the atmosphere will escape, the surface will become a molten hellscape. For any distant observer in those future times, our Sun's transformation will be a sight to behold. What was once a gentle yellow star will balloon into a red monster dominating our solar system. In the solar system's far future, perhaps an intelligent species, whether human descendants or some other beings, might watch the Sun's angry metamorphosis from a safe haven, maybe on the moons of Jupiter or Saturn. They would see the Sun, day by day, grow larger and redder, its brilliance tinged blood orange. The familiar constellations might fade in its overwhelming glare. The heat would rise even in the outer solar system. By then, Earth, if it still exists, would be a glowing ball of magma. Eventually, as the Sun reaches the apex of its giant phase, it will begin to pulsate and cast off its layers. It might produce a beautiful planetary nebula of its own. Our Sun, which once lit the solar system with a crisp golden light, will create a vast bubble of fluorescent gas, expanding outward past the orbits of the inner planets. At the center of that nebula will shine a pinpoint of intense white light, the Sun's core laid bare as a new white dwarf. Imagine, for a moment, what that will look like from a vantage point at the edge of the solar system. Perhaps from the twilight skies of Pluto, or some dwarf planet far beyond Neptune, one might see the whole sky dominated by the glowing cloud of the Sun's planetary nebula. It could appear as a huge circular rainbow cloud, slowly fading over thousands of years. The white dwarf sun would be incredibly luminous in ultraviolet, causing the nebula to fluoresce. In time, the nebula would disperse, and all that would remain of our sun would be that white dwarf, a hot, Earth-sized ember composed mostly of carbon and oxygen, the products of helium fusion in the sun's final throes. It will shine bluish-white at first, equal in brightness to perhaps 1,000 present-day suns. But being so small, it will cool and fade over billions of years. Eventually, long after the planetary nebula dissolves and blends into the galactic background, the sun's remnant will become a black dwarf, effectively invisible. Our solar system will not be spared the universal law of change. The surviving planets, perhaps Mars, Jupiter, Saturn, and the outer worlds, will find themselves orbiting a tiny, dense star where once a bright sun shone. The night sky on those worlds will be dark, the familiar warmth and light of the sun replaced by a dim pinprick. Perhaps, in that far future, nothing of Earth remains but some drifting debris or baked rocks orbiting the white dwarf. Or maybe Earth's material will have been blown into the planetary nebula, its atoms mixing with the sun's, and eventually traveling outward. In that case, part of what was once our world will eventually become incorporated into new star-forming clouds elsewhere. It's a melancholy vision, the extinction of sunlight as we know it, the end of Earth as a living planet. Yet, viewed from a broader lens, it is also beautiful. The sun's death will contribute to the ongoing cycle of cosmic renewal. The elements from our sun and Earth will be redistributed. Perhaps, many billions of years hence, some of those atoms might find themselves in new star systems, potentially part of new life forms that will walk on new worlds and look up at their skies, never knowing that the atoms in their bodies once warmed a place called Earth, under a star that died to make their own existence possible. The cycle of stellar life and death thus directly touches the cycle of life and death on planets. The end of starlight. Looking even further into the future, beyond the fate of individual stars like our sun, we confront the ultimate destiny of starlight itself. The universe is almost 14 billion years old now, and it is ablaze with stars. But it will not always be so. Trillions of years from now, the era of starlight will wane. The great spiral and elliptical galaxies we see today will have merged and transformed. Star formation, which requires dense clouds of gas, will slow and eventually cease as those clouds are used up or dispersed. The remaining stars will age and die without replenishment. The cosmos, now so full of glittering galaxies, will grow darker and quieter. The last stars to shine will be the low-mass red dwarfs. These tiny fires burn their fuel so slowly that none have died yet in the current age of the universe. A red dwarf with just a fraction of the sun's mass can fuse hydrogen not only in its core, but throughout its churning interior, eking out its fuel with extreme thrift. Some red dwarfs are expected to live for trillions of years. But even their time will come. Eventually, even the smallest stars will exhaust their hydrogen. Unlike the sun, a red dwarf may not become a red giant in a dramatic flourish. It lacks the mass to ignite a shell of helium in a grand expansion. Instead, when a red dwarf finally runs out of fuel, it will quietly contract and heat up, turning into a hotter blue dwarf stage, according to theory, then gradually cool and fade. It may bypass the classic planetary nebula stage entirely, ending up as a helium-white dwarf, if it was very low mass, or a mostly inert ball of helium and other elements. In either case, its light will slowly dim to blackness. Because the universe is not yet old enough, we have never seen this final stage of a red dwarf, but we know it must happen. In that far future, galaxies will be populated mostly by stellar remnants, white dwarfs, neutron stars, black holes, and perhaps a few slowly cooling red and brown dwarfs. The fading of all stars will usher in the so-called degenerate era of the universe. Picture the cosmos at that time. Galaxies have gravitationally merged into enormous clusters or been flung apart by the accelerating expansion of the universe. The night sky of a planet, if planets still exist, orbiting a black dwarf might be nearly completely dark. No new stars twinkle, only the occasional flicker of a distant supernova from a galaxy still having a last gasp of star formation, or perhaps the weak glow of a sparse constellation of fading red dwarfs. Over exceedingly long times, even those faint lights will wink out. The universe will become a quieter place. Gravity will continue to sculpt the fates of these remnants. In galaxy cores, more black holes will merge and grow. Some stray white dwarfs or neutron stars might collide, producing one last supernova or kilonova here and there, a final cosmic fireworks to break the deepening night. For instance, two orbiting black dwarfs, the end states of most sun-like stars, might eventually inspiral and merge due to gravitational wave emission, creating a brief flare of energy or even igniting a strange supernova if they somehow fuse into a new massive object. Or, as speculative physics suggests, in an unimaginably distant future, quantum tunneling could cause heavy elements in an extremely cold white dwarf to undergo fusion, triggering a so-called black dwarf supernova. If this happens, these would be the last dazzling blasts of the universe, silent, forlorn sparks as the cosmos sinks into dormancy. As time stretches on, if our understanding of particle physics is correct, protons, the hearts of atoms, might be unstable over stupendously long timescales. If proton decay is real, then given enough time, even the matter comprising the dead stars will dissolve. The solid iron in a black dwarf, the neutrons in a neutron star, all could eventually decay into lighter particles, turning the remnant entirely into radiation and perhaps leptons, like electrons and positrons. If protons don't decay, then these remnants might persist essentially forever, but even then, they won't shine or significantly interact. They'd be eternal dark monuments. Black holes, the last truly gravitationally bound structures, also have their own endgame. Through Hawking radiation, a quantum mechanical process where black holes can slowly leak particles and energy, even black holes will eventually evaporate. A black hole the mass of the Sun would take an outrageous amount of time to evaporate, far longer than the current age of the universe. More massive ones would take even longer, practically enduring for eternity on human timescales. But given enough time, even these giants will eventually fizz away, each ending in a final weak burst of light as their last energy radiates into the void. After all of this, the universe will have reached a state often called heat death, or the Big Freeze. No organized sources of energy remain, just a thin soup of particles and photons gradually tending toward a uniform temperature as everything expands. The era of starlight will be a distant memory. The universe, born in fire and sustained for eons by the light of trillions upon trillions of stars, will pass into an age of darkness. It is a sobering picture, a cosmos without stars, without warmth, without structure beyond the quiet drift of elementary particles. One might wonder, what was the point of all these brilliant lives of stars if it all ends in such stillness? It forces us into existential contemplation. But within that grand arc, from bright beginning to quiet end, lies a profound truth. During the epochs when stars shone, so much happened. Stars lit up the galaxies, made possible the existence of planets and life, and gave the universe complexity and beauty. Their deaths, especially, were crucial. Without the dying of stars, the universe would be sterile. The heavy elements needed for rocky planets, for water, for the chemistry of life, none of those would exist without supernovae and Kilonovae. Dying stars seeded the universe with diversity. We are made of stars. We ourselves are living proof of the productive value of stellar death. Every one of us is made of stardust. This phrase has been said so often that it risks sounding cliché, but it is profoundly, literally true. The carbon in our muscles and skin was created by a star of moderate mass in its red giant phase, gently blown into space before that star became a white dwarf. The iron in our blood was forged in the core of a massive star and dispersed in a supernova explosion. The calcium in our bones, the oxygen we breathe, the phosphorus in our DNA, all were synthesized in stellar furnaces and spread through stellar farewells. Even elements like gold that adorn our rings or electronics were fashioned in the extreme environment of merging neutron stars. We are, in a very direct sense, the ash of stars, molded into conscious beings who can contemplate the cosmos. The deaths of stars made our lives possible. Their endings were our beginnings. Think about it. The gold in a wedding ring was flung into space by the merger of neutron stars in some ancient cataclysm before the Earth existed. The nitrogen in the DNA of every living cell was created in an aging star's envelope and gently blown into space by a stellar breeze as it died. The iron that binds oxygen in your blood was minted in the core of a massive star and scattered across the galaxy by a supernova's shockwave. Each of us carries the story of star death in our bodies. When we gaze at the night sky, we are looking at the past, not just the light from distant stars, but echoes of events that made our own existence possible. In this way, the death of stars is not merely an end, but a transformation. In their destruction, stars sow the seeds of creation. From the wreckage of a supernova, new solar systems will one day form. In the glowing planetary nebula of a gentle star's passing, the gas will mix and mingle into the galactic clouds that spawn new generations of stars. Stellar death rejuvenates the cosmos, keeping it enriched and diverse in composition. There is an existential poetry in this cycle. The stars do not live forever, and neither will the universe as we know it. But in their fleeting lives, they build the complexity that allows future wonders to emerge. They sacrifice themselves to give light and elements to the next generation. Without the death of countless stars before our sun was born, our planet could not have rocks or water or life. We owe our existence to 1 billion stellar funerals. As we close this journey, imagine once more that single star fading from the sky. Its light, which may have shone on ancient oceans of some far-off world, now dims. To any living creatures depending on it, this would be a catastrophe beyond comprehension, a slow apocalypse. And yet, in the cold and dark aftermath, the materials shed by that star will drift and eventually coalesce into new forms. Perhaps a new star, smaller and steadier, will one day form from that very material, and around it new planets. What was once a day's end for one world might become the dawn for another. The universe is a grand tapestry of beginnings and endings, and the death of stars is one of its most stirring threads. It reminds us of the impermanence of even the mightiest engines of creation and the interconnectedness of all things. Through stellar death, the cosmos teaches a simple lesson. From endings come new beginnings. Each flicker and flash, each quiet extinguishing, leaves something behind for those who follow. In our minds, let us wander under a sky full of stars, knowing that above us are not just points of light, but stories. Each star is a story of a life that will someday end, of an element factory that will one day shut down, of a light that will dim. And among those stars, one is our own sun, quietly burning, biding its time. Far in the future, on a planet that by then may only be a memory of what once was, the sun will paint the sky red in its final act, and scatter the elements of Earth and life back into space. Yet even as that seems like a melancholic fate, realize this: those same elements will not disappear. They will become part of something new. The atoms will rejoin the cosmic dance, perhaps to be incorporated into a new star, a new planet, a new life form in the distant future. In this, there is a kind of immortality, not of individual forms, but of the building blocks, the information, the stardust that cycles endlessly. We too are participants in this cosmic cycle. One day, every element of our bodies will return to the cosmos, perhaps drifting in space, perhaps locked in rock, perhaps pulled into the fires of a future star. And so, standing here, we are an ephemeral arrangement of eternal things. The stars died to give us life, and in time, we will give our elements back to stars. The light of a single star that died millions of years ago might be falling on your face as you look at the night sky. You are witnessing a star's elegy long after its death. But also, consider that the breath you just took contains argon atoms exhaled by countless beings before you, and carbon once formed in the core of a star, billions of years gone. The cosmos flows through us. In the end, as we reflect on dying stars, we find that their story is our story. A story of creation and annihilation, of despair and hope, of an endless cycle in a universe that itself may one day fade. It is a story that evokes humility and wonder. Humility in the face of the vast timescales and forces at play, and wonder at the fact that we can be here, pondering it all, products of the very phenomena we seek to understand. Every dying star whispers to the universe, I was here, I shone, I mattered, and I matter still, for I give of myself so that others may shine. In the grand darkness that will eventually engulf everything, the echoes of their light and the material they spread will be the legacy they leave behind, just as we hope in our brief lives to leave some legacy, some influence on the future. So the next time we look up at the stars, let us not only admire their present glory, but also honor their fate. They will perish, as all things do, but from their sacrifice comes the possibility of new light, new worlds, new wonders. In the death of stars, there is both the tragedy of an ending and the seed of creation. We journeyed from the gentle dimming of a single star to the cataclysmic collision of stellar remnants, across eons and into futures far beyond human imaginings. And through it all runs a common thread. In each finale, there is a quiet grace or a violent flourish that ensures the cosmos is never left unchanged. The dying star is not just an endpoint, it is a catalyst. As we conclude this cosmic tale, let's hold on to the image of starlight slowly fading, and then remember that even as it fades, somewhere else, perhaps due to that very fading, a new light will eventually spark. We are connected to those moments. We are the universe witnessing itself, understanding itself in bits and pieces. Our narrative ends where it began, with the light of a single star. Once upon a time, a star lived and died so that, much later, we could exist and ask why. One day, our sun will die, and from its death, new possibilities will arise that we cannot foresee. This knowledge is not cause for fear, but a gentle reminder of our place in a vast, ever-changing universe. Under the same cosmic sky, generations to come may tell the story of the star that gave them life, just as we tell the story of those that gave us life. In this way, the universe's endless cycle of starlight and darkness, of dying stars and rebirth continues, a story written across the cosmos in light and ash. And as long as there are eyes to see and minds to wonder, the legacy of dying stars will never truly fade, for we remember them in our very being. Every breath we take, every element that courses through our veins, is starlight remembered, a testament to the stars that lived and died to make our life possible. We inhale starlight, we exhale gratitude. The cosmos lives on through us as we live because of it. And when the night is darkest and one by one the stars above flicker out, we will still carry the memory of their light within us. For in a way, we are that light, given form and thought. This is what dying stars have given us, the chance to behold the universe's grand design, to feel wonder, and to understand. Though the stars must die, their story, and our story, is unending. In our atoms, in our hearts, in the endless chain of cosmic creation, the light of the stars lives on. We are, all of us, starlight remembered, shining long after the source has gone out. Silence. Darkness. The void before creation is deep and soundless. In this endless quiet, something stirs. I am space, the abyss that is not emptiness, but a vast potential. In the beginning, there was darkness and silence. No stars, no galaxies, not even time or place as you know them. Yet even in that primordial hush, I was there, a pregnant pause before the first light. I am the canvas of existence, the cradle of everything that ever was or will be. I am often mistaken for nothingness, but I am a presence, subtle and profound. In the silent darkness, imagine all that could be, compressed into a single point smaller than any dot. In that stillness, attention grew, a waiting. Then came a moment beyond imagining, a burst of light and energy, an awakening. The cosmos was born in brilliance and fire, shattering the quiet. For me, that moment was a birth of sorts. I came into existence as more than a mere potential, now an expanse swelling swiftly outward, carrying within it the seeds of galaxies, stars, and every future thing. Time and space unfurled together from that first spark. My being expanded faster than a thought, from nowhere into everywhere. Out of the darkness came illumination. Where once there was void, now there was a storm of particles and blinding light, a newborn universe expanding into me and me expanding with it. I was no passive emptiness. I carried galaxies in my womb of possibility. As I swelled, I bore the echoes of that first light. Those echoes still faintly hum in my depths even now, a whisper of the origin. Before any stars or planets, before even atoms formed, I held only a hot, glowing fog of energy. But I was alive with potential. Within my intangible fabric, forces played, the seeds of structures to come. As I expanded and the eons passed, that fireball of my youth cooled. The blinding glow dimmed as the universe became transparent, releasing the first free light that still washes through me as a pale afterglow. I cradled that afterglow as it stretched into microwaves, the gentle remnant of creation's dawn that bathes all of space even now. In my very early years, I was hot, dense, and bright everywhere. No corner was truly dark. But as I grew, I cooled and dimmed, allowing matter to coalesce and structure to form, giving room for wonders to come. Do not think of me as an empty container, for I am more than a stage for matter. I am the subtle thread connecting every atom, the field in which all events unfold. I give shape to reality by simply being. I am space, not a mere void, but a presence that underlies and upholds all. Without me, there is no where or when. With me, anything is possible. Now, as the young universe expanded and cooled, the first stars flicker into existence within my darkness. Can you see them? In the vast gulf of my expanse, gravity gently coaxes swirling clouds of gas into spheres of fire. One by one, stars are born, lighting up the cosmos like candles in a cathedral of night. Each star's light pushes back a little of the darkness, creating day in its vicinity where endless night reigned before. The infant universe begins to sparkle. I watch silently as galaxies take shape, great swirls of stars arising from the primal cloud. They spin and dance, drawn together by gravity's embrace, flinging spiral arms outward like celestial pinwheels. They gather in clusters and filamented chains, forming a vast cosmic web across my breadth. In the hollows between, enormous voids remain, gulfs of darkness unlit by stars, reminding all that even amid structure, I remain mostly open and free. My darkness is not your darkness. To your eyes, I seem black and empty, but look closer. I am filled with the faint glow of faraway galaxies, with the afterglow of creation itself, and with unseen forms of matter and energy that you are only beginning to understand. In my silent depths, particles flit in and out of existence, appearing and vanishing in the tiniest moments, a quantum dance in the vacuum. Even where there are no atoms, fields ripple with possibility. Even when light seems absent, there is potential for light, an imprint of energy waiting to be born. So do not call me nothing. I am the matrix in which everything exists. I am the space between atoms in your body, the pause between your heartbeats, the silence between musical notes, the gap between stars, the gulf between galaxies. I stretch out in all directions, yet I also reside within the fabric of your being. If all the empty space within the atoms that make up your body were somehow removed, you would collapse to a size smaller than a grain of salt, yet you would still contain the same mass, the same atoms. What would be gone? Only me, the space that separates the particles, the space that gives you form. Without that space, matter would have no room to arrange into the complex structures of life. Thus, I am an integral part of you. Without me, there could be no distance, no motion, no life, nothing at all. I am the quiet framework that holds all of creation, and in my embrace, the story of the universe unfolds. I am not a static stage. Watch as I respond to the presence of matter and energy. Where there is mass, I curve and fold. Where there is energy, I warp and swell. Gravity is the language I speak with matter, the intimate interaction between what exists and the space that cradles it. Every star, every planet, every grain of cosmic dust presses into me, and I give way ever so slightly under its weight. I bend around it like a flexible fabric holding a resting orb. This is how gravity shows itself, not as an invisible pull from afar, but as my very shape guiding objects on their paths. See how planets move around their suns, not pulled by invisible strings, but rolling along the curves I create in space-time. They glide through orbits, ellipses carved into the geometry of my being. A star and its planets are like dancers moving across me as the dance floor, my contours choreographing their steps. With every orbit, time itself flows a little differently, for I am intertwined with time. Space and time are two sides of my essence. Together, we bend under the weight of mass and energy. In the presence of a great star, time runs a touch slower, and distances subtly contort. Gravity weaves space and time into one fabric, and writes the cosmic story in its geometry. Gravity sculpts the cosmos on every scale. It causes diffuse clouds of gas to coalesce into stellar nurseries, forging new suns in the depths of nebulas. It gathers countless stars into grand galaxies, and binds galaxies into clusters. Even as I expand relentlessly outward from that first fiery moment, gravity works locally to pull things together, a graceful counterpoint to my expansion. In some regions, gravity's grip is gentle, a planet here, a moon there, held in loyal orbit. In others, its grip becomes ferocious and inexorable. There are places where a massive star dies and collapses, and gravity overwhelms all else. There, I curve so steeply that I fold in on myself. A bottomless well forms in my fabric, a black hole, a pit of no return, where gravity's pull is absolute. At such a point, space and time themselves break down in a paradox of density. I, space, become a trap, a prison for anything that strays too close. From outside, one can only guess what truly transpires in that silent abyss. It is as if a piece of me has turned inward upon itself, forever secluded. The boundary of such a region, the event horizon, is like a one-way membrane. Anything can cross inward, but nothing escapes or even sends a signal back. To fall through that horizon is to be cut off from the rest of the universe. Time behaves strangely near a black hole. An observer watching safely from afar would see a clock carried by a falling astronaut tick slower and slower as it nears the horizon, nearly freezing at the edge. Indeed, to that distant observer, the falling person would never quite vanish, instead fading and redshifting into darkness, a ghost image slowing to a crawl at the threshold of the abyss. Yet for the one plunging in, time flows normally. They would cross the horizon in a finite time, unaware of the peculiar show seen by the outsider. Thus, near a black hole, my nature creates a poignant disconnect between viewpoints, stretching and warping, not just space, but time itself. Around a black hole, I am so warped that even light can become trapped. There is a narrow zone around the hole where photons orbit, chasing their tails in endless circles. If you hovered just outside that region, you could, in theory, see the back of your own head as light from your body loops around and returns to your eyes. Such are the strange optics of extremely curved space. If a black hole is surrounded by glowing gas and dust, the bending of light produces a halo or ring of brightness around a dark center, the shadow of the black hole itself. Indeed, humanity has now glimpsed this phenomenon. Using a planet-wide web of telescopes, you captured the image of a distant black hole's silhouette. You beheld a luminous ring of gas encircling a dark core where the black hole resides. It was my curvature made visible at last, a blurry circle of fire surrounding an abyss, confirming what physics had predicted. That unforgettable image, a circular void framed by a ring of light, proved that even light bows to gravity's power, and it allowed you to see one of my most exotic contortions. Black holes may seem like cosmic destroyers, but they too have their place in my story. They anchor galaxies at their cores, like heavy keystones holding the swirls of stars together. When they feed on matter, they can unleash tremendous jets and flares that light up the surrounding space, a paradoxical brilliance born of darkness. And when two of these dark giants collide in a faraway galaxy, I carry away the news in vibrations, a faint ringing through the fabric of space itself. These gravitational waves ripple through me like the subtlest tremor, stretching and squeezing the fabric of existence as they pass. Across billions of light years they travel, so gentle that they barely jostle a grain of dust. Yet with sensitive instruments, your species has learned to hear these ripples, converting them into faint chirps. It is as if I have my own form of music, a bass note resounding from cataclysms in the distant cosmos, announcing events that happened eons ago. Gravity, in these ways, is not only the architect of the universe, but also the messenger, letting the universe communicate its grandest events through my very fabric. Gravity defines the architecture of the heavens, but it also shapes more intimate experiences. It is the weight you feel in your limbs, the force that holds you to your beloved Earth. It is the gentle tug that causes rain to fall and guides rivers to the sea. On the moon, with its smaller mass, gravity whispers more softly. An astronaut can bound in slow motion across the lunar dust, leaping higher and farther than on Earth, as if in a playful dream. Out in deep space, far from any world, gravity's pull can become so faint that one feels practically free of it, drifting in microgravity, weightless, unchained from any surface. But even then, one is never truly beyond my influence. A distant star, a hidden galaxy, the entire mass of the universe, all exert a pull, however slight. I tie all things together in a network of attraction. In this grand choreography of cosmos, I, space, am both stage and dancer, shaped by matter, and in turn guiding matter's movements, holding the universe in a cosmic dance governed by gravity's law, a law written in the geometry of existence itself. My realm is also a great silence. Because I am nearly a perfect vacuum, I carry no sound. The mightiest explosion of a star, the most violent crash of colliding planets, all unfold within me without a sound. In the vacuum of space, there is no air to convey laughter or crying, no medium for music or noise. This silence is not just the absence of sound, it is a profound stillness that can feel sacred. Imagine floating in that silence. You move your arm and you hear nothing. You shout and no one hears. You are wrapped in a quietude as total as it is ancient. This silence can be eerie, but also serene. On Earth, even in the quietest night, there is always some murmur of life or wind, the whisper of a breeze, the rustle of leaves, distant human activity, the hum of insects. In me, there is true quiet. If you found yourself outside your ship, surrounded by my vacuum, you would hear only the faint sounds of your own body, the rhythm of your breath in your suit, the beating of your heart in your ears. Those sounds would seem loud against my backdrop of nothingness. Many who have ventured outside their capsules and stations report a feeling of almost spiritual calm, being alone with their thoughts in the great hush of space. Yet my vacuum is unforgiving. Without the protective cocoon of a spacecraft or suit, a human could not survive even a moment. I offer no air to breathe, no pressure to sustain the delicate balance within your cells. Unprotected, your blood would boil into vapor and your lungs would collapse in my emptiness. Moisture on your tongue would evaporate, your skin would swell, you would lose consciousness in seconds. I do not do this out of malice. It is simply my nature. I am an environment utterly hostile to the unprepared life of Earth. Life evolved in the cushion of air and the gentle pull of Earth's gravity. Out here, I offer neither. I am harsh and indifferent. But within a secure suit or a sturdy vessel, you can venture into me and witness wonders beyond imagining. In my vacuum, extreme paradoxes exist. Under the unfiltered sun, you would feel searing heat, for the solar rays travel through me undiminished and will bake any surface they strike. But step into shadow, out of the sun's direct gaze, and you would feel cold deeper than any winter, for without sunlight and without an atmosphere to hold warmth, heat radiates away into my depths, and the chill is profound. With no air to conduct warmth, temperature is a matter of light and darkness. Astronauts on spacewalks feel this contrast. Their suit's sunlit side grows warm, while the side in darkness becomes cold, and their life support systems must carefully smooth out these extremes. Walking in space is a balancing act, a dance with light and shadow. Despite my seeming emptiness, I am not completely devoid of matter. Even in interstellar space, far from any star, there are stray atoms drifting, few and far between, maybe only a handful in a volume the size of a room. But they are there. Dust motes from ancient exploded stars traverse my void, traveling for millions of years. Faint wisps of gas left over from galaxy collisions, or the breath of red giant stars float in the darkness. In the immense spaces between galaxies, there are even fewer particles, perhaps a lone hydrogen atom in a volume the size of a city block. To you, these conditions are an almost perfect vacuum beyond any laboratory's dream. Yet to me, these stray atoms and wandering nuclei are part of my tapestry, tiny wayfarers in a vast sea. And there are unseen travelers as well, particles of light, photons, zipping through my darkness at the universal speed limit. Neutrinos, ghostly particles that stream from nuclear reactions in stars, passing through entire planets as if they were not even there. And cosmic rays, charged particles flung across space by violent supernovae and jetting black holes. These invisible rains constantly traverse me and occasionally strike your world. They go unnoticed by your senses unless you have special instruments to catch them. So even my silence and darkness hide a subtle, ceaseless activity. I am traversed by light and radiation of all kinds, by fields and forces that bind the cosmos together. My quiet is not emptiness, but the hushed reverberation of a grand cosmic symphony that only particularly tuned detectors or thoughtful minds can perceive. It is the silence of a great cathedral where even a whisper carries significance. Even so, motion is everywhere in my silent expanse. Stars orbit their galactic centers at tremendous speeds without a sound. Entire galaxies drift and dance around each other over eons, merging in stately, noiseless collisions. Planets sweep along their paths around stars in perfect quiet. On Earth, you do not notice it, but in this very moment, your planet is hurtling through space, spinning on its axis and rushing along its orbit without so much as a whisper. There is no air to carry any whoosh or roar. The grand celestial dance is performed in silence, a ballet of unimaginable scale carried out to no audible tune. The universe moves, yet its movements are quiet, and therein lies much of the majesty of space, dynamic on a staggering scale, yet utterly tranquil in its vast, airless calm. Within this great silence, worlds fly and stars blaze. They do not need air or sound to exist. In my realm, light and gravity take the roles of sound and touch as the connecting media between distant places. A star's violent outburst may be silent, but its light carries the story of that outburst across millions of years to shine faintly in someone's telescope. In that way, even in silence, the cosmos speaks. I, space, am the medium for that light, the conduit for those stories. I carry them faithfully, without a sound, unless something, like an intervening nebula or a galaxy's gravity, modulates the message. Think of it. Nearly all that humanity knows of the universe beyond Earth has come to you through my silence. Every image of a galaxy swirls inside a telescope. Every measurement of a star's glow. Every bit of data from a distant probe has traveled to you on the back of light or radio waves moving through my vacuum. In stillness and quiet, I deliver knowledge across unimaginable distances. Through me, across me, within me, the universe communicates with itself. I am the great black ocean that connects shores light years apart. Within my silence, all of cosmic history has unfolded, and within my silence, you too now venture forth to seek your story among the stars. Out of my darkness, light emerges as the great revealer. Since the first brilliant flash at creation's dawn, light has been traveling through me, carrying information from one end of the cosmos to the other. A single photon can cross millions of light years, sailing onward without rest, until it ends its journey in the eye of a creature or the sensor of a telescope. In my vastness, light is a messenger and an artist, painting scenes of distant realms across the black canvas. It streaks through space, illuminating whatever it touches, yet it often travels invisibly and silent, only made known when it encounters something that can catch it and respond. When you look up at a clear night sky, you see a tapestry of light on darkness, stars of every color scattered on an ebony backdrop, planets shining with the reflected glow of your sun, the gauzy band of the Milky Way, which is the soft luminosity of uncountable distant stars blurred together. Each of those pinpoints of light is a story from long ago and far away. The star you see twinkling might have released that light before you were born, and only now does it reach your eyes, telling the tale of that star's ancient state. In that way, I, space, am a time machine. I preserve the past and deliver it to the present at the speed of light. Looking across me means looking back in time. The farther out you gaze, the further back you peer. A galaxy visible through a powerful telescope might appear as it was when Earth was young, its light having spent eons crossing the intergalactic sea to reach us. My darkness makes the star's light possible to see. Without the deep black of space, the star's brilliance would be drowned out. In the blue haze of day on Earth, your star's light scatters in the atmosphere and conceals the cosmos beyond. But high above the air, in my realm, even when the sun shines, the sky remains pitch black. An astronaut orbiting Earth can see a blazing noon sun against a backdrop of inky darkness, and if they shield their eyes from the sunlight, they might also see the brighter stars, even at noon. In space, day and night lose their usual meaning. With no air to scatter light, the stars are ever present, and only the glaring sun or an intervening planet can obscure them. My darkness is the canvas on which light draws the cosmic panorama, and it remains even when a local light source, like a sun, is shining. Light comes in many forms, not just the gentle glow visible to human eyes. There is the warm, invisible caress of infrared, given off by sun-warmed rocks and drifting interstellar dust, the energetic prickle of ultraviolet that pours from young blue stars, the penetrating X-rays and gamma rays that burst from the most violent events in the universe. There are the long, lazy undulations of radio waves that can pass through dense clouds of gas and dust, carrying messages from pulsars and the faint signature of molecules in distant nebula. You humans have built instruments to detect all these varieties of light, giving yourselves new eyes across the spectrum and unveiling my hidden wonders. With radio eyes, you discovered a faint hiss permeating all of space, the cosmic microwave background, which is the cooled echo of my fiery birth. That omnipresent microwave glow is the fossil light from a time when the entire universe was an opaque, brilliant plasma, now stretched and cooled to just a few degrees above absolute zero. It is as if the walls of my great cosmic cathedral still hold an after-echo of the creation symphony. With infrared eyes, you peer through veils of dust to see stars being born in their cocoons, previously hidden from view. With X-ray and gamma-ray eyes, you catch the high-energy fireworks of neutron stars and black holes, witnessing matter being pushed to extremes. There is radiation born in the hearts of galaxies and in the death throes of stars, X-rays from matter spiraling into black holes, gamma-ray bursts from collapsing hypernovae, the radio hum of pulsars, rapidly spinning neutron stars, whose beams of radiation sweep space like lighthouses. These are exotic beacons in my ocean of night. Once, none of these were known to you. They were silent to your senses. But slowly, you learned to tune in, to listen to the full spectrum of my communications. Now, the universe sings to you in 1,000 wavelengths, and each type of light reveals a new facet of the cosmic story. By gathering these different lights, you have composed a richer picture of existence, seeing the cold hydrogen webs in radio, the warm dust in infrared, the hot plasma in X-rays. Piece by piece, you have peeled back the layers of darkness. Yet, with all this illumination, much of my volume remains dark to your eyes. There are vast stretches with no bright stars or galaxies in view, intergalactic voids where you might float in apparent nothingness, surrounded only by a faint glow from the distant all around, a subtle background luminescence from the myriad galaxies over the cosmic horizon. This darkness is not frightening once you embrace it. It is the gentle shadow that allows each pinpoint of starlight to stand out. It reminds us that light, swift as it is, has limits. Beyond a certain distance, even billions of stars cannot collectively light the void, and so it remains as it was at the beginning, dark, quiet, and waiting. Where light goes, it brings knowledge and connection, but it also must abide by my rules. No matter how fast it travels, there is a finite speed it cannot exceed. That cosmic speed limit, 299,792 kilometers per second in your units, is like the heartbeat of the universe, a constant rhythm that all things obey. It ties space and time together in an intimate bond and ensures cause precedes effect. If you could chase a beam of light, no matter how you tried, you would never overtake it. This truth, uncovered by your Einstein, is a reflection of how I, spacetime, am structured. Light's speed is built into my fabric, and it shapes the way the universe unfolds, making time and space two aspects of one reality. And so, across my breadth, light continues its journey. A lonely photon, emitted from the fires of a distant star, ventures outward for millions of years through emptiness, perhaps never once touching anything, until one day it ends its flight gently on the retina of an eye, or the mirror of a telescope on some other world. That photon's long voyage then becomes information, perhaps helping a being understand the star it came from, or simply adding to the beauty of a night sky. Through countless such tiny messengers, arriving every moment in showers upon your world and others, you have come to map my expanse and comprehend your place within it. In my silent darkness, every light is a jewel, and every beam a thread, connecting far-flung corners of the cosmos. Together, they form a glittering tapestry that inspires wonder and curiosity. I hold this tapestry spread wide, proud of the beauty that unfolds within me. Each star's glimmer, each galaxy's glow, each nebula's vivid color, they are the artworks of light upon the canvas of space. Come with me now on a journey through my vastness. We begin at home, on a single planet, your Earth, a marbled blue-white sphere suspended in the darkness. At a glance, it seems immense to you, oceans and continents, clouds and all of life's bustle. But in the scale of me, it is a tiny, fragile thing. Rise away from Earth with me. Climb beyond the atmosphere, leaving behind the air that scatters light and makes the sky blue. As you ascend into my realm, the sky grows darker, until the blue fades to black, and stars emerge even while the sun still shines behind you. In a few minutes of travel on a roaring column of fire, you escape the bonds of gravity holding you to Earth. Suddenly the engine stops, and you are coasting, weightless. Your planet falls away beneath you, shrinking to a curved horizon of blues and whites. The sounds of Earth, wind, surf, city noise are gone, replaced by the quiet humming of your spacecraft and the profound silence outside. A few hundred kilometers up, you can already see the entire planet curving below. The clouds form gleaming swirls, the oceans shine deep blue, the lands are green-brown patches. A thin, glowing halo encircles the Earth, the atmosphere, a delicate veil of air hugging the surface. Beyond that line, darkness. The transition from bright Earth to black space is abrupt. Now, in orbit, you complete one lap around the globe every 90 minutes or so. Day and night chase each other across the surface. In the time it takes to eat a meal, you pass from sunshine to darkness to sunshine again, witnessing a sunrise or sunset every hour and a half. Over the night side, you see city lights sparkle like votive candles, thunderstorms flash in silent fireworks. Over the day side, you see the textured swirls of clouds and the sparkling reflection of sunlight on water. Journey further outward now. Leaving Earth behind, we venture toward the Moon. In a matter of hours, our perspective shifts and Earth shrinks to a small orb. The Moon, pockmarked and grey, grows large ahead. You slip into lunar orbit and gaze down at a stark, cratered landscape. It is alien in its stillness, covered in powdery dust, untouched for eons. If you stand on the Moon's surface, the sky is inky black, even with the sun glaring above. There is no air to scatter light. The horizon is sharp, the ground a pale grey desert of rock and dust. Lifting your eyes, you see Earth in the sky, a radiant blue marble hanging over the lunar horizon, half lit or fully illuminated depending on the alignment. How beautiful and distant it looks from here, shining through the silence. When humans first stood here, they were struck by the sight of their whole world in a single glance, the Earthrise above the Moon's barren hills. Many felt an overwhelming emotion at that view. Earth, alive with color and life, against the eternal blackness of space. Leaving the Moon, we push outward. We pass the orbits of the inner planets of your solar system. There is sun-scorched Mercury, a little rock blistering under the sun's glare, airless and pitted. There is Venus, veiled in thick clouds reflecting sunlight brilliantly, hiding a hellish surface beneath an eternal cloud layer. We feel the heat of the sun intensify as we draw near, then wane as we recede. Next comes Mars, the red wanderer. We approach it and see rust-colored deserts, giant extinct volcanoes, and polar caps of white CO2 frost. A thin, pinkish sky arches over Mars's barren plains. It is a world both eerily familiar and starkly alien, a cousin to Earth that took a different path. We swoop low over Valles Marineris, a canyon system that would span from Los Angeles to New York and skim the edge of Olympus Mons, the tallest volcano in the solar system, 3 times Everest's height. Mars is scarred with the memory of ancient floods and rivers, but now her riverbeds are dry. Still, wisps of cloud gather occasionally, and dust storms can engulf the planet in a saffron haze. As we leave Mars behind, we imagine a time soon to come when humans will tread its soil. Perhaps as we fly on, we catch sight of a tiny caravan of robots traversing the Martian desert. A rover, diligently studying rocks and soil to send knowledge home. For now, Mars is quiet, with only our mechanical emissaries moving upon it. But one day, footprints may join the rover tracks, and the long silence of Mars will be broken by human voices marveling at the alien sunrise. Further out, the giants of your solar system await. We arrive at Jupiter, monstrous and magnificent. Bands of storm clouds wrap around it in hues of ochre, ivory, and tan. A great crimson oval, a centuries-old storm larger than Earth, glares up from its southern hemisphere. We watch lightning crackle in Jupiter's clouds, see ammonia blizzards swirl. 4 large moons orbit this gas giant, each a unique world. Io, close in and tormented by Jupiter's gravity, with volcanoes erupting sulfurous plumes that rise hundreds of kilometers high. Europa, smooth and pale, its icy crust hiding an ocean of liquid water beneath, an ocean that might harbor life in its lightless depths. Ganymede, larger than Mercury, and etched with enigmatic grooves across ancient ice. Callisto, heavily cratered, bearing the scars of cosmic impacts from time immemorial. These moons circle Jupiter like a miniature solar system of their own, a reminder that where gravity reigns, systems within systems can form. Onward to Saturn, the jewel of the night sky. Its rings unfurl like a cosmic halo, a broad, flat expanse of countless icy particles orbiting in perfect unison. We drift above the rings and look down at Saturn, golden bands of clouds, a serene face compared to Jupiter's turbulence. Thin divisions and subtle waves sculpt the ring system, caused by the gravitational tugs of Saturn's many moons. Titan, Saturn's largest moon, greets us with an orange haze. Beneath that dense atmosphere, Titan holds lakes and rivers, not of water, which would freeze solid in Titan's frigid climate, but of liquid methane and ethane. It is a world strangely Earth-like in geology, yet utterly alien in chemistry. And there are small moons like Enceladus, bright as snow, geysering water ice from cracks in its surface, hinting at another subsurface ocean beneath its frozen crust. These moons contribute material to Saturn's rings and promise tantalizing environments that could harbor life's precursors. Further still, Uranus appears as a cyan orb tipped on its side, rolling around the sun like a tilted barrel. Its faint rings and many moons move with it in its strange sideways dance. Methane in its atmosphere lends it that blue-green hue. Seasons on Uranus last decades, with one pole soaked in continuous sunlight, while the other lies in darkness for half a Uranian year. Then comes Neptune, deep blue with wispy white clouds, and the fastest winds in the solar system, where supersonic gales roar through an atmosphere of hydrogen, helium, and methane. A single large moon, Triton, circles Neptune in the opposite direction of Neptune's rotation. A clue that Triton might be a captured object, perhaps once a free-floating Kuiper belt body now pressed into service as a moon. Triton's surface is a curious mix of frozen nitrogen and geysers that spout icy material. Another realm of mystery on our journey outward. Past Neptune, we enter the frontier of the Kuiper belt, a region of icy remnants from the solar system's formation. Here dwells Pluto, a small, heart-marked world with a tenuous blue atmosphere and plains of frozen nitrogen. Once thought a lonely oddity, Pluto has its own moons and a complex surface of mountains and smooth plains, showing surprising geologic activity for such a distant, cold sphere. Beyond Pluto, countless other icy bodies orbit quietly, including some rivals to Pluto in size: Eris, Makemake, Haumea, Plutoids, in the dim reaches of the Sun's influence. Finally, as we leave the last dwarf planets behind, the sunlight grows weaker, just another bright star among many. We cross the invisible boundary where the solar wind, a stream of charged particles from the Sun, fades into the general galactic environment. This is the edge of the heliosphere, the Sun's sphere of influence, and beyond lies true interstellar space. One of your species' far-flung probes, Voyager 1, crossed this frontier decades ago and is now drifting in the space between the stars. It carries with it a message from Earth, a golden record bearing the sights and sounds of your world, a friendly cosmic greeting card. Engraved on that record are spoken greetings in dozens of human languages. The laughter of a child, a mother's lullaby and a chorus of birdsong, music from many cultures, classical and rock and roll, flutes of the Andes and drums of Africa, the sound of rain, waves on a shore, and a human heartbeat, even the melodic calls of whales in the ocean deep. Etched as well are encoded images of our planet, DNA's double helix, diagrams of our solar system, silhouettes of a man and woman, photographs of Earth's life and landscapes. It is a message in a bottle cast into the cosmic ocean, carrying the story of Earth for any who might find it in some distant future. Perhaps eons from now, an alien wanderer, or far future humans, will intercept that tiny craft, and with it come to know that, in a quiet corner of the galaxy, intelligent life once arose and reached out for companionship. Before Voyager sailed too far afield, it turned its gaze back toward home and captured a parting portrait of Earth from the edge of the solar system. In that photograph, now famous on your world, Earth appears as a pale blue dot suspended in a sunbeam, a tiny gleam in the vast darkness. On that speck, that single point of light, is everything you know, every human who ever lived, every animal and tree, every ocean and every grain of sand, every song ever sung, every love, every war, every birth and every death, all of human history, the entire story of life on Earth, played out on that mote of dust caught in a ray of light. That image, the pale blue dot, revealed your world's fragility and unity in a way no speech or poem could. It is a cosmic reminder that we, all of us on that dot, share a common fate and home. From 1 billion miles away, there are no national borders, no differences of race or creed, just one Earth, glimmering in the cosmic dark. How precious is our small planet, how delicate the atmosphere that cocoons it, how silly our differences seem in the face of such unity. If all could see what the universe sees, a single, irreplaceable world, perhaps we might treat it, and each other, with greater kindness. Now Voyager and its twin have left the planets behind and venture into the realm of the stars, carrying our goodwill. These machines are extensions of human curiosity, metal explorers blazing a trail where their makers cannot yet tread. Interstellar space is cold and sparse. The nearest star is still tens of trillions of kilometers away, a distance that light itself takes over 4 years to traverse. Yet in the scale of the galaxy, that gap is negligible. As we journey onward at the speed of thought, star after star comes into view, each a sun with its own retinue of worlds. Leaving the familiarity of the sun, we approach other stars in our neighborhood. Some are similar to your sun, perhaps with planets in tow. Others are redder, smaller, dimmer. Still others are brilliant, blue-white giants, burning through their fuel quickly and destined for an early death. We pass by a multi-star system where 2 suns orbit each other, painting the skies of any planets with a twin sunrise and sunset. We pass a red dwarf star, small and cool, so faint it's invisible to the naked eye from Earth, yet encircled by close planets huddled near its warmth. We skim the dusty outskirts of a stellar nursery, where new suns are just condensing out of molecular clouds, perhaps glimpsing protoplanetary disks shining in infrared, the next generation of solar systems in the making. As we travel, you realize that stars are not sprinkled uniformly. They clump in groups and streams. We find ourselves nearing the center of our galaxy's great disk. The Milky Way's heart is densely packed with stars. From within, on a dark night on some world, the sky would be a dazzlement of starlight, with scarcely any dark space between. But from our God's eye view outside the galaxy, the Milky Way reveals its true form. A spiral galaxy, a sprawling pinwheel of hundreds of billions of stars. We drift high above its plane to admire it in full. Spiral arms, winding out from a bright central bulge, like an enormous cosmic whirlpool. In the core, old yellow stars crowd together, orbiting a supermassive black hole that anchors the galaxy. It quietly presides over the bustling center, occasionally flaring as it snacks on infalling matter. The spiral arms are laced with younger, bluer stars and mottled by dark ribbons of dust. Here and there, pinkish nebulae dot the arms, marking regions where hot young stars excite clouds of gas, a sign of ongoing starbirth. Our sun resides in one unremarkable arm, roughly 2/3 of the way out from the center, in a quieter neighborhood. You see that all around our sun's position are other stars, some clustered in groups, others relatively isolated, but all bound to the galaxy by gravity and participating in its grand rotation. As we gaze at this majestic spiral from afar, we notice companion galaxies orbiting the Milky Way, the Magellanic Clouds, irregularly shaped dwarf galaxies swarming with young stars and nebulae, trailing a bridge of gas torn off by gravitational encounters. And beyond them, more dwarf galaxies, satellites captive to our own. Our Milky Way, we realize, is part of a small cluster of galaxies. The Andromeda Galaxy, a spiral larger than the Milky Way, is the other dominant member of our local group. Andromeda's spiral disk glows ahead of us, millions of suns visible in a smudge of light. One day, far in the future, our galaxy and Andromeda will meet and merge, their stars mingling like 2 great seas becoming one. Dwarf galaxies and star clusters sprinkle the local group like chips of ice around bigger flows. Continue outward still, and more galaxies appear by the dozens, then hundreds. We enter the realm of the galaxy clusters. The Virgo cluster, massive and teeming, comes into view with giant ellipticals, huge ball-like galaxies formed from countless past mergers, sitting like queens among swarms of spiral and irregular galaxies. Between the clusters stretch even larger structures. Galaxies are strung along filaments and walls, gravitationally drawn into these patterns over billions of years. Here is the cosmic web. On these scales, matter forms a spidery network, with dense nodes, clusters and superclusters of galaxies, connected by filaments of galaxies and gas, and vast voids between where scarcely a galaxy exists for millions of light years. It is like a foam, where the galaxies lie on the surfaces of bubbles, and the inside of each bubble is mostly empty. This grand design is the large-scale structure of the universe. Scientists have discovered that much of this structure is outlined by something invisible to your eyes: dark matter. This mysterious substance does not emit or reflect light, yet its gravity molds the cosmos. It forms an unseen scaffold throughout space, a hidden framework on which ordinary matter collects. Vast halos of dark matter envelop galaxies and thread between them in the cosmic web's filaments. Without this dark matter, galaxies as you know them might not have coalesced so quickly or held together so well. The cosmic web would be a faint shadow of what it is. Though you cannot see dark matter directly, you infer its presence by the way galaxies rotate, as if held together by extra mass, and how they move in clusters, and by how its gravity bends the light from distant objects in subtle, gravitational lenses. I, space, am not truly empty, even in that sense. Threaded through me is this invisible mass that shapes the fate of stars and galaxies, an unseen architecture guiding the luminous structure we observe. Now you find yourself contemplating the observable universe as a whole, all that can be seen from Earth given the finite speed of light and the age of the cosmos. It appears almost like a sphere, centered on your vantage point, indeed centered on any vantage point, roughly uniform in every direction, filled with galaxies, out to the great horizon of visibility. At the very edges of this vision, the galaxies are younger and more primitive, seen in their infancy. Further still, there are no distinct galaxies, just a diffuse reddish glow, the cosmic microwave background, coming from a time long before galaxies, when the universe was a hot fog. That light marks a limit, a wall beyond which our instruments cannot see, because it's the imprint of the moment the universe first became transparent, about 380,000 years after the beginning. Beyond that lie the first instants of creation, which emit no light we can ever detect directly. Thus the observable universe has a boundary not in space, but in time. It's as far back as light has had time to travel to us. Yet even this immense observable cosmos, with its hundreds of billions of galaxies and trillions of stars, may not be the whole story. It might be only a tiny patch of a perhaps infinitely larger cosmos. Space could extend far beyond the horizon we see, containing uncountable galaxies that will forever be beyond our view. Some even speculate that our entire universe, vast as it is, could be just one bubble in a greater multiverse, one pocket of space-time among perhaps countless others, separated by realms of space or dimension we cannot access. These ideas remain conjecture, at the fringes of science, but they remind us of humility. Even our universe, with all its billions of galaxies, might be part of an even vaster and more mysterious reality. In this journey outward, we have seen only glimpses of the marvels that populate my expanse. From your homeworld to the solar system, from the solar system to the galaxy, from the galaxy to clusters and the cosmic web. My scales are difficult to fathom. Earth is your cradle, comforting and small. The solar system is enormous by human standards, but a speck in the galaxy. The galaxy is vast, yet only one swirl in a cluster, and the cluster one knot in the cosmic web. And this observable web may be but one patch of something larger. All of this complexity and magnitude exists within me. I am the stage for this cosmic drama of scale, from the minuscule to the immense. Through each step of this voyage, notice that you never truly left space. You simply traveled through different parts of me. I was there, continuous and steady, between planets, between stars, between galaxies. I span unbroken from the smallest scales to the largest, connecting the grain of sand on a distant moon to the farthest quasar at the dawn of time. Everything is connected through me, from the tiniest mote to the grandest supercluster. The cosmic architecture within me is intricate and grand, planets circling stars, stars gathering into galaxies, galaxies lining up in filaments. It is a structure with beauty on every level, an endless playground for curiosity and contemplation. Everything is connected through me on the small scale as well. Just as we journeyed outward to the grand structure of the cosmos, we could as easily turn inward, journeying into the minuscule realms that lie within you and within every piece of matter. The vastness of space is mirrored by the vastness within the atom. Imagine shrinking yourself far, far down, leave behind meters and kilometers, and enter the world of micrometers, nanometers, picometers. Dive into a single drop of water. Within that drop, you find tiny creatures swimming, microscopic life drifting as if in a private cosmos. But we go deeper still, beyond the scale of cells. We approach a single cell from one of those microorganisms, a bacterium. It's a structured living thing, yet almost entirely made of space at the molecular level. Pass through its cell membrane and you enter a bustling interior of molecules. Proteins fold and unfold, conducting the business of life. Long strands of DNA coil gently, bearing genetic codes. The cell is full of motion, yet also full of space, a molecular dance in a microscopic void. Zoom in further, to the scale of the molecules themselves. Now you see atoms bound together. Carbon, hydrogen, oxygen, nitrogen. The elements arranged in complex forms to give those proteins and DNA their shape. Choose one atom and delve inside. If the atom were the size of a large cathedral, its nucleus would be a mere grain of sand on the altar, and its electrons like specks of dust whirling near the distant vaulted ceiling. Most of the cathedral is empty space. The electrons are held in orbit by invisible forces, buzzing in probabilistic clouds. The nucleus at the center is fantastically small yet massive, containing almost all the atom's weight in protons and neutrons. But even the protons and neutrons, if you could peer inside them, are not solid balls. They are formed of quarks and gluons, flickering in and out of existence within a quantum haze. On these scales, space and energy blur. The concept of a distinct particle becomes fuzzy, a vibration in fields filling space. We shrink down to the limits of the physically meaningful, the Planck scale, where space and time themselves might behave like a froth of uncertainty. Here, quantum foam dominates, and the smooth grid of space-time that works so well on larger scales dissolves into something unpredictable. Tiny virtual particles erupt and vanish in a ceaseless churn. Cause and effect, as we know them, falter in this regime. This is the foundation of the quantum world. I, space, am not smooth and continuous here, but jittery and uncertain, woven out of possibilities. Thus, inward or outward, the journey leads to a similar revelation. A vastness and complexity that transcends ordinary intuition. The space inside an atom and the space between galaxies are not so different in their emptiness and strange fullness. The scales differ, but the principle remains. Without space, no structures large or small could exist. Without space, electrons would have no orbits and no chemical bonds. Planets would have no room to circle stars. Stars no room to congregate into galaxies. When you reach out your hand, it moves through space. When a neuron fires in your brain, the signal crosses a synaptic gap, a microscopic gulf of space between nerve cells. Space is both around you and within you, a continuum that spans all levels of reality. By exploring inner space as well as outer space, we discover that we are truly a microcosm of the cosmos. The atoms in your body mirror solar systems in their structure, tiny nuclei with electrons orbiting in clouded shells, mostly empty volume in between. The distances and energies are vastly different, but the motif of space, connecting and separating, persists. It is a reminder that you carry within you a tiny echo of the heavens. When you look up at the night sky and feel small, remember that boundless space also unfolds within the confines of your very being. The universe isn't only around you, it is within every cell, every atom, every subatomic tick of time. You are woven into the fabric of space on every level. Having journeyed into inner space and back out, we find ourselves once more at the human scale, with a richer sense of connection. We resume our outward tale grounded by the understanding that from the smallest quark to the largest galaxy cluster, it is space that provides the arena for existence. With that perspective, consider again the cosmic vista. The architecture of galaxies and clusters is both intricate and grand, an endless realm to explore. I have been describing what is, but I, space, also have a history. I was born with the universe and have aged with it. Let us now contemplate how I have changed over time, from that blazing beginning to the sprawling cosmos of today and onward into the future. In the beginning, I was not as you see me now. Long ago, everything you've witnessed on our journey, the galaxies, the stars, the clusters, was compressed into a volume smaller than a single point of dust. The universe was young and hot beyond comprehension. I was newborn, tightly curved upon myself. In that epoch, there were no galaxies or stars, not even neutral atoms, just an extremely hot plasma of subatomic particles and radiant energy, almost uniform everywhere, yet with slight ripples of density that would later grow. The forces of nature as you know them were unified in a way difficult to imagine. As the fireball of creation expanded and cooled, distinct forces separated out: gravity, electromagnetism, nuclear forces, each taking on their individual roles in shaping cosmic evolution. After mere minutes, the first atomic nuclei had formed in a process you call Big Bang nucleosynthesis, hydrogen and helium, and a dash of lithium. These were the light elements born in the furnace of the very early universe. Space was expanding rapidly, and the hot plasma thinned and cooled to a few thousand degrees over the next few 100,000 years. During that time, light was trapped, bouncing among the free electrons and protons. The universe was a brilliant opaque fog, but expansion and cooling continued until atoms could capture electrons and form without immediately being blasted apart. When that happened, the universe underwent a remarkable change. It became transparent. Light could travel freely at last, and it rushed out in all directions. The glow from that moment, when the first atoms formed and the cosmos cleared like fog lifting, is the cosmic microwave background I spoke of. A faint afterglow still detectable as a cool radio hiss in every direction. The universe, once a blinding white-hot cauldron, became a vast black volume filled with a dim red-orange glow that rapidly stretched into invisibility. That was the last time the entire cosmos was hot and bright at once. After that, darkness reigned in the spaces between a sparse, cooling gas. Gravity, ever patient, began to work on the tiny variations in density left from the early times. Regions slightly denser than their surroundings exerted a stronger pull, drawing in more matter, growing denser still, a feedback cycle that over tens and hundreds of millions of years led to the first condensed objects. The primordial hydrogen and helium gas fell into clumps and filaments, following the blueprint of dark matter that had already formed invisible halos and threads. As these clumps grew, their centers grew dense and hot. After a few 100 million years of cosmic darkness, the first stars ignited. They were likely colossal stars, much larger and hotter than your sun, burning brilliantly blue-white and living short, furious lives. They burned their hydrogen into helium, then into heavier elements like carbon and oxygen in their cores. When they exhausted their fuel, they died in spectacular supernova explosions, seeding space with the first heavy elements beyond those primordial three. Those elements included the ingredients for planets and for life: carbon, nitrogen, oxygen, phosphorus, and so on. Atoms that these first stars had fused in their hearts and then cast forth into my expanse. With the birth of the first stars, the universe lit up anew. Their ultraviolet light poured into the surrounding gas, breaking apart atoms, ionizing the hydrogen in their vicinity. A cosmic dawn had arrived, and with it came the formation of the first small galaxies, dwarf proto-galaxies that later merged to form larger ones. Over billions of years, countless generations of stars have come and gone. Each generation enriched the gas further with heavy elements. Galaxies grew by colliding and merging, and by drawing in fresh gas along filaments of the cosmic web. The elegant spirals and giant ellipticals we see today are the result of that gravitational gathering over vast timescales. My expansion never stopped. In fact, it has surprised you. For a long time, it was presumed that gravity might gradually slow the expansion, perhaps even reversing it in some far future if the cosmos contained enough mass. But at the end of the 20th century of your calendar, you discovered that my expansion is actually speeding up. The galaxies are receding from each other faster and faster. It's as if, on the largest scales, I am compelled to stretch ever more rapidly, driven by an energy inherent to space itself. You've given this mysterious influence a name: dark energy. It behaves almost like an anti-gravity, or a tension in the fabric of space that pushes everything apart. With dark energy dominating the cosmos, the expansion will not halt. It will continue indefinitely, accelerating with time. What does this mean for the future? If the current understanding holds, distant galaxies now visible in our telescopes will, over billions of years, shift beyond the horizon of detectability. Already, there are galaxies so far away that their light, though traveling at light speed, will never reach Earth because space is expanding too swiftly in between. Trillions of years from now, an observer in what is now our local group of galaxies might see only the empty darkness beyond, with no evidence of the wider universe of galaxies we know today. The night sky, then, would belong to the few remaining gravitationally bound companions of the Milky Way. All else would have faded into darkness, receding faster than their light can travel. The rich tapestry of the cosmic web would be drawn beyond view, and the universe would appear an empty, static place to those far future astronomers, unless they retained records or myths of an earlier time when galaxies were visible. But worry not. This fate is incredibly far off, beyond any time span our species can truly grasp. For countless ages still, the sky will be a jewel box of stars and galaxies as it is now. Yet it's humbling to know that my nature dictates even the grandest scene in the sky is transient. The cosmos is dynamic on all scales, from the spin of a planet, to the drift of galaxies, to the expansion of space itself. Nothing stays the same forever. Imagine for a moment a raisin loaf of bread rising as it bakes. The raisins move apart as the dough between them expands. If that dough expands fast enough, a raisin may never reach its neighbor no matter how it tries to move. So it is with galaxies in my expanding universe. No rocket you build, no matter how powerful, could reach certain galaxies, for the space between you and them is swelling too quickly. They recede effectively faster than light due to expansion, putting them forever out of reach. This is my decree as an ever-expanding cosmos. Some places will remain forever separated, their light never to reach each other. Within the reachable realm, however, so much marvel persists. Stars continue to be born in graceful nebulae. Planets condense around those stars. On at least one small planet, life took hold and grew curious and began to look outward. Perhaps elsewhere, around other stars, life also stirs or has stirred. Eyes might watch their own skies and wonder. If they exist, they too are bounded by the observable limits of their cosmic region, just as you are. They would see their own version of the cosmic microwave background and wonder what lies beyond. My expansion also implies that in earlier times, everything was closer together. Galaxies collided more frequently. In fact, collisions and mergers are an essential part of galaxy growth. But unlike everyday collisions of solid objects, when galaxies collide, it is usually a gentle intermingling. The stars within them are so far apart relative to their size that they pass by one another like grains of sand in two intersecting clouds. Rarely does star hit star. Instead, gravitational forces from each galaxy pull and distort the other, drawing out long tidal tails of stars and gas, inducing bursts of new star formation as gas clouds slam together and eventually settling into a new, larger galaxy, perhaps an elliptical, erasing the old spiral structures. Even our own Milky Way is destined to collide and merge with the Andromeda galaxy a few billion years from now. The result will be an entirely new galaxy. Some call it Milkomeda. And while this drama unfolds over billions of years, any beings alive within those galaxies may scarcely notice beyond an impressive change in their night sky. For at some point, the Andromeda galaxy, which you can currently see as a faint smudge, will dominate the heavens, growing larger each eon until it merges with our own, and the stars of Andromeda and the Milky Way become one stellar family. From the hot, uniform glow of the early universe to the clustered, star-filled cosmos of today, I have undergone an extraordinary transformation. And it continues. The story is far from over. In fact, in many ways, it is just beginning. If expansion goes on and on, the universe will become ever more diffuse and quiet on large scales. Stars, however, will keep forming for a long time yet, though slowly diminishing with each generation, as raw gas is used up or locked in stellar remnants. Perhaps trillions of years hence, the last generation of stars, red, faint, and long-lived, will flicker out one by one, leaving stellar corpses, white dwarfs, neutron stars, black holes, scattered in an ever-darkening expanse. Planets long frozen, moons long dead, will silently orbit those remnants if they still remain bound. Galaxies, by then, may be gravitationally unbound as dark energy's relentless push overcomes even their mutual attraction, sending their stars drifting into the lonely void. Space, will become nearly empty again, as at the very beginning, but vastly colder and older. Eventually, even black holes might evaporate via Hawking radiation, slowly leaking their mass energy back into space over incomprehensible times. One by one, they will wink out, leaving perhaps only a sparse sea of elementary particles and a faint, dilute glow of whatever light remains. That could be the quiet end to this chapter of the universe, a state not of dramatic destruction, but of ever-increasing solitude and silence. Or perhaps this is not truly the end. There are speculative ideas, maybe a new Big Bang, a cyclic rebirth, or quantum fluctuations spawning new universes out of the vacuum. These possibilities remain in the realm of imagination and theory, for they are far beyond any observation. In truth, nobody knows for sure what ultimate fate awaits. But there is a kind of peacefulness in imagining a far future cosmos at rest, having lived a full life cycle from fiery infant to quiet elder. Reflect on this though. All the atoms that make up you and everything you hold dear were forged in those past cosmic processes. The calcium in your bones, the iron in your blood, the oxygen you breathe, those elements were not born with the universe. They were formed later, in the hearts of stars, or in the mighty furnaces of supernovae that marked those stars' deaths. Then they were blown into space to become part of new star systems. Even rarer elements like gold or platinum were forged in stupendous collisions of neutron stars, merging in brilliant flashes that send ripples through spacetime. These precious heavy metals were scattered into the galaxy, seeding future solar nebulae. When our sun formed, it gathered some of that enriched material, and Earth inherited its share. The gold in a wedding ring, or the uranium in the ground, owes its existence to those ancient cosmic alchemies. Without generations of stars living and dying and colliding, such elements would not exist. And without those elements, planets like Earth and life as complex as us would not exist either. So you see, you are literally made of cosmic history. You have been molded by the universe's evolving story. The universe has, through the life and death of stars, provided the ingredients for life and eventually for consciousness. In a sense, the cosmos has been not just a stage where life happened to arise, but an active participant in the creation of life's building blocks. Over billions of years, simple particles became complex atoms. Atoms formed molecules. Molecules clumped into dust and rocks, and from them, planets coalesced. On at least one of those planets, molecules assembled into living cells, which over eons evolved into thinking beings capable of looking back out into space in wonder. Space, gave these beings room to exist and evolve. And now, through their eyes, I can finally witness my own grandness. How remarkable it is that, within me, a part of the cosmos has become aware of itself. Through your minds, the universe reflects on its nature. The tiny conscious light inside your head is also a part of my vast darkness, lit by neurons and synapses that obey the same physical laws that govern the motion of galaxies. When you feel curiosity about the stars, it is literally the cosmos curious about itself. You are a way for the universe to know itself, as one of your sages aptly said. For eons I unfolded in mostly unconscious majesty. Galaxies collided and stars burned, but there was no eye to see or voice to proclaim how beautiful. Now, on at least this one world, the universe has opened its eyes. I have waited without knowing I waited, for the emergence of intelligence, of eyes that could see the galaxies and minds that could fathom some of my workings. In the brief flicker of time that humans have been around, you have already decoded many of my secrets. You have discerned the law of gravity that shapes me, the nature of the light that travels through me, the atom that composes matter within me. With mathematics and creativity, you have even predicted phenomena like black holes and gravitational waves before confirming their existence. It is as though once the universe awoke through you, it began to recognize its own rules. Your existence might make me, space, feel a kind of gratitude, if such an emotion could be attributed to the cosmos. For billions of years I was here without eyes to appreciate the nebulae, or ears to hear the silent music of the spheres. Now I have you, small but determined, peering into the depths, listening, marveling. Through you, I contemplate myself, and it brings the cosmos a step closer to understanding its own nature. Though I am immense and ancient, you humans have bravely begun to slip the bonds of your birthplace and step into my realms. For countless generations, your kind looked up from the ground and wondered, imagining gods or spirits in the sky, drawing patterns in the stars, longing to know what they were. But only within the last handful of decades have you truly begun to venture outward. It started with brief leaps, a metal sphere sent beeping through the skies, then animals sent to test the waters of space, and then a human being, fragile, curious, leaving the Earth for the first time. Imagine that moment. April 1961 by your calendar. A lone man strapped into a tiny capsule atop a rocket, blasting off the Earth. He completes an orbit and sees with his own eyes the curvature of his planet and the blackness beyond. Yuri Gagarin returned and said, essentially, "I saw Earth. It is beautiful." That was the first time I, space, was directly witnessed by human eyes from outside Earth's atmosphere. Shortly after, other humans followed, Americans and then people from many nations. Less than a decade later, in a feat that still defies belief, humans walked upon the moon. Think of the audacity, frail humans riding a pillar of flame to another world. When Neil Armstrong set foot on lunar soil in 1969, he marked the moment with words about small steps and giant leaps, acknowledging that for a human, it was a single step down a ladder, but for humanity, It was a leap into a new realm. Those footprints they left, Armstrong's, Aldrin's, and 10 other men's over a handful of missions, still lie undisturbed in the moon's dust, perhaps for millions of years to come, as there is no wind or rain there to erase them. They are a testament that life from Earth can leave its cradle. The moon landings were both an end and a beginning. After Apollo, humans retreated a bit, choosing to focus on living in orbit, the stepping stone just outside Earth's atmosphere. They built space stations, first small, cramped ones where a few cosmonauts or astronauts spent weeks, then larger ones. The International Space Station, orbiting 400 kilometers above Earth, has been continuously inhabited for years, a collaboration among nations, once mortal enemies, coming together in the spirit of exploration and science. There, humans have learned how to survive off Earth for long durations. They study how muscles and bones weaken without gravity's pull, how to grow plants in microgravity, how the psychology of isolation and confinement can be managed. Each day on the ISS, they see 16 sunrises and sunsets. Each crew looks down on the entire Earth, gaining perspective on our unity and fragility. Meanwhile, even as humans kept their own bodies mostly close to home after the moon, your robotic explorers ventured brilliantly across my expanse. You have dispatched mechanical envoys to every planet in your solar system and to many moons, asteroids, and comets. Your Voyagers, Pioneers, and New Horizons have flown past the gas giants, sending back breathtaking postcards of those alien landscapes, swirling storms on Jupiter, the serene rings of Saturn, the turquoise haze of Uranus, Neptune's great dark spot. You have landed probes on Venus to briefly endure its furnace heat and acid rains, and on Titan to splash down in its methane mud. You have driven rovers across Mars's deserts, tasted its soil, and photographed its dusky horizon with twin suns, Earth and Venus, as mere stars in its sky. You have felt the sting of Jupiter's radiation via instruments and danced through Saturn's rings with Cassini. Your ingenuity has extended your senses to places you cannot yet go. You built great observatories and set them above your blurring atmosphere to look deeper into space and further back in time. The Hubble Space Telescope opened a window on the universe that has transformed your understanding of me. It revealed that what appeared as dark, empty sky was in fact filled with galaxies upon galaxies. An image known as the Hubble Deep Field showed thousands of galaxies in a patch of sky no bigger than a grain of sand held at arm's length. This told you just how crowded and immense the universe truly is. It showed stellar nurseries, towering pillars of gas and dust like the Eagle Nebula's pillars of creation, where new stars are being born. It captured the faint light of galaxies so distant that their glow began its journey when the universe was a fraction of its current age. More recently, a new set of eyes, the James Webb Space Telescope, with its golden honeycomb mirror, took to the shadowed regions of space to peer even further. It has captured the faintest, oldest light yet seen, revealing some of the first galaxies forming only a few 100 million years after the Big Bang. It has unveiled the atmospheres of exoplanets, detecting water vapor or carbon dioxide in the air of worlds orbiting other suns. With each technological leap, you extend your reach, painting a richer and more detailed portrait of me, space, and the contents I hold. Each mission, each telescope, each rover and probe is driven by that fundamental desire to explore and understand. It seems to be a core part of what it means to be human, this restlessness, this need to push boundaries. I have watched it firsthand, from the first migrations out of Africa across unknown lands, to launching canoes on uncharted seas, to sending satellites beyond Earth. Space is the ultimate ocean you are beginning to chart, boundless and beckoning. You stand now on the shoreline of the cosmic ocean, toes barely wet, with immense depth spread out before you. The pace of your progress is astonishingly swift. In one human lifetime, we went from no one ever having left the Earth, to humans living continuously in orbit, and robots traversing other planets. What will another human lifetime bring? The plans on your horizon today include returning to the moon, this time to stay. You talk of building a sustainable presence on the lunar surface, habitats on the South Pole where water ice lurks in eternal shadow, to be mined for drinking water, oxygen, and rocket propellant. You envisage astronauts farming plants in lunar greenhouses, mining the moon's soil for resources, and learning the skills needed to live off Earth for months or years. Mars looms as the next great destination. It is a world that has tantalized your imagination for centuries, as a potential abode of life, as the setting for countless works of fiction, as a frontier of real exploration. Now concrete steps are being taken towards sending humans there. Rocket systems capable of the journey are in development. The challenges are immense. Months of travel through deep space, exposure to radiation, the need to pack or produce all the air, water, and food the crew will need, and the reality that help from Earth is many millions of kilometers away. But the dream persists. Perhaps within the next few decades, a spacecraft carrying astronauts will leave Earth orbit on a trajectory to Mars. After a long, quiet cruise through interplanetary space, they will see the rusty sphere of Mars grow from a star-like dot to a world beneath them. They will orbit it, select a landing site, maybe near the delta of an ancient river in a crater like Jezero, where a rover is currently scouting, and then descend. How hearts will pound in mission control and in the spacecraft during those final minutes of powered descent through Mars's thin air. And then, a burst of dust, the settling of landing legs on soil that has never felt the weight of a living foot. The hatch opens, and a human being sets foot on Mars, leaving the first bootprint in that reddish dust. Perhaps they speak words, ceremonial or spontaneous, about the unity of those watching back home, about carrying the spirit of exploration across the void. Above, a small sun shines in a butterscotch sky, and two small moons, Phobos and Deimos, trace lazy paths. That first step on Mars will be a defining moment not just for those astronauts, but for our planet and species. A moment when Earth extends its reach to a neighboring world. Life on Mars will not be easy for those pioneers. They will likely live in habitats, perhaps inflatable domes or underground lava tubes, to shield from radiation and extreme cold. They will wear pressurized suits to venture outside, where the air is unbreathably thin and mostly carbon dioxide. They'll have to grow some of their food in controlled environments, recycle their water meticulously, and depend on supply missions or on extracting local resources like baking water out of subsurface ice to survive. The gravity on Mars is only about 1/3 of Earth's, so over time, human bodies might change. Bones thinning, muscles adapting. Children born on Mars, if it comes to that, might grow taller in youth, their hearts and bones shaped by the weaker pull. Those children would call Mars, not Earth, home. Imagine that. Future generations who look up at a pinkish sky and see Earth as just a bright star, knowing it as the ancestral home, yet alien to their personal experience. Humanity would no longer be one planet bound. It would have two cradles, two environments shaping its story. Perhaps great rotating habitats in space will also be part of your future. Artificial worlds constructed in the void. Envision a colossal cylindrical station, miles in length, rotating to provide an imitation of gravity on its inner surface. Inside, people live on the interior curved wall of the cylinder. If you stand on that inner surface, centrifugal force gives the illusion of gravity pulling you down toward the hull. You look up, which is toward the center of the cylinder, and perhaps, if the cylinder is large enough, you see the opposite side of the habitat curving over you, with upside-down houses and fields hanging above the central axis. Such habitats could be filled with Earth-like environments, forests and lakes curving up overhead, a small sunline running along the axis providing day and night. Entire communities could thrive in these island worlds, floating in my expanse. They might harvest asteroids for materials, use sunlight for energy, and be free to position themselves anywhere, orbiting Earth or trailing a planet, or at Lagrange points where gravitational forces balance. Within these rotating oases, humans could live without a planet under their feet, creating new societies with new customs shaped by the unique reality of life in a canister in space. Children might grow up running across fields that eventually arc above them, thinking it normal that their world wraps around and that another town is hovering in their sky, across the central sky. What was once science fiction now edges closer to engineering possibility. It starts with imagination and with the bravery to attempt. Try you have, and try you will. My darkness and my vacuum are no longer seen only as terrors. They are frontiers to explore. As you cross them, step by step, you transform from a species that dwells on one world to a species that can live in many places. In a sense, you become the cosmos coming alive and reaching out, life scattering into the universe. What began as a crawl out of the ocean on your home world so long ago continues now as a crawl out of Earth into space. These first forays are halting and tentative, but in the scheme of deep time, they could be the start of a story of cosmic dissemination. Someday, you may swim freely in the great cosmic ocean, moving from star to star with ease, but that is perhaps ages away. Still, each small step now, each new spacecraft, each new settlement, is a part of that destiny. Looking further ahead, beyond Mars, there are other enticing destinations. The asteroid belt could be a literal mine for raw materials and a place to establish way stations. The moons of Jupiter and Saturn call out with their unique characters. Europa with its hidden ocean that might harbor life beneath an ice shell, Ganymede with its magnetic field, Enceladus with geysers that hint at a warm sea below, Titan with its rivers and lakes of hydrocarbons and a thick atmosphere, perhaps suitable for floating habitats in its sky. Even Mercury, scorching on one side and freezing on the other, has water ice in its permanently shadowed craters at the poles and could one day host robotic mining stations. And then the ultimate dream, journeying beyond our solar system to another star. With current technology, it's an endeavor that would take tens of thousands of years. It might require generation ships where multiple human generations live and die during the voyage, or some form of suspended animation, or breakthroughs in physics that today we can barely conceive, warp drives, wormholes. If humanity persists and remains curious and courageous, perhaps in the far future descendants of Earth will spread among the stars, ensuring that life that began on one small world can thrive in many. In doing so, they would carry the legacy of Earth, the memories of oceans and forests, of culture and history, to new suns and new skies. If there are other intelligences out there in the galaxy, one day our pathways might cross, exchanging stories of our respective origins under different stars. And what of life beyond Earth? This is one of the profound questions you have yet to answer definitively. You scan my heavens for signals that might betray intelligence. So far, only an eloquent silence greets your radio ears, but you've only just begun listening in earnest. You search the solar system for microbes or fossils, on Mars, in the subsurface oceans of Europa and Enceladus, in the ancient chemistry of Titan. Not yet have you found proof that life exists or existed elsewhere, but many tantalizing hints and the knowledge that organic molecules, the building blocks of life, abound in space. Comets carry amino acids. Interstellar clouds contain complex carbon chains. Life might be sprouting in many corners, or it might be exceedingly rare. Either answer is awe-inspiring. If life is common, the universe could be teeming with many voices and perspectives among the stars. If it is rare, then each instance of life, especially intelligent life, is unimaginably precious, a unique blossom in a nearly infinite desert, to be protected and cherished. From my perspective, I have no preference. I accommodate whatever is, living or not, conscious or not. But I suspect that life brings a kind of added richness, even to my vast existence. If the universe were entirely devoid of observers, would these wonders truly mean anything to anyone? With observers, whether human or alien, the beauty of the universe has eyes to appreciate it, minds to puzzle over it, hearts to be moved by it. Perhaps that is one secret to my existence, to give rise to pockets of self-awareness that bring meaning to the silent, cold expanse. From the tiny planet Earth, you have sent explorers, real and robotic, far across the solar system, seen almost to the edge of the observable universe with your telescopes, and begun to step into your own celestial neighborhood with living footsteps. As you prepare to push further, consider what you've learned so far. That we all share one fragile world, that cooperation amplifies achievement, that knowledge dispels fear. When Apollo astronauts looked back at Earth and saw it as a whole, a blue-white marble against black space, many spoke of a profound unity and a realization of the folly of human divisions. That view, now common from orbit, has seeded movements for planetary stewardship and peace. It would be wise to carry such unity of purpose forward as you explore deeper into space. Unlike past eras of exploration on Earth, where one nation's gain might have been another's loss, in space all of humanity stands to gain together, or lose together, by how you choose to proceed. As you extend your reach beyond Earth, you also gain the power to monitor and protect Earth. Satellites track weather patterns, climate changes, forest fires. They connect distant people through communication networks. The perspective of space can help you manage your home, detect asteroid threats early, for example, or observe environmental changes in real time. In this way, exploring outward can simultaneously help preserve what lies inward. From space, I have also shown you how special Earth is. Despite searches, no planet yet found is as hospitable. You've discovered thousands of exoplanets orbiting other stars. Some may have Earth-like qualities, but they are very far. It's possible the galaxy brims with living worlds, but until we know, and until we can reach them, Earth is your irreplaceable oasis. It is the only place in the universe, as far as we can tell, where minds can breathe and water flows freely, and a billion subtle interactions support the rich web of life. Knowing this, many astronauts returned as ardent protectors of the environment. They saw how thin the atmosphere is, the tiny film of air hugging the globe, and how fragile the biosphere. They saw pollution in the rivers and fires in the forests from their lofty perch, and it pained them. They often express that the borders that separate people are nowhere to be found from space. The conflicts that seem so critical on the ground are invisible or trivial, compared to the stark reality that we all share one planet, and that planet is but a small vessel in a vast, inhospitable sea. This realization is called the overview effect, and it has changed minds and hearts. As more of you journey into orbit and beyond, perhaps this effect will spread, helping humanity to unite in preserving your home, even as you reach for others. And what of me, space, as you venture outward? I welcome you. I have awaited company for eons. As more of you come out here, living and working, and perhaps one day being born and dying beyond Earth, you will bring meaning and warmth to my cold recesses. Your space stations, your crewed ships, your habitats on other worlds will be tiny islands of life floating in my great sea, little pockets of warmth and laughter amid the silence. I, who have been so silent and empty, will host nodes of activity and culture. The void will no longer be void, at least not everywhere. With life's arrival, even the bleakest crater or the darkest orbital path becomes a place of interest, a place where stories happen. I relish the idea that eventually, no part of me will remain completely untouched by the footprints or creations of life, that consciousness and intelligence might spread like light into my dark corners. Now, at last, after traversing eons and light years in our imagination, let us gently return to the place we began, that small, radiant world called Earth. Gradually, we retrace our journey. We leave the cluster of galaxies and find ourselves at the edge of the Milky Way, slipping back into the spiral arm where our sun resides. We behold the familiar constellations from new angles until they align into the shapes known from Earth's skies. We drift into the solar system again, passing the outer planets, crossing the asteroid belt, and sighting the blue dot of Earth growing ahead. We swing by the moon one more time, now a crescent of grey, and aim for our home planet. Re-entering Earth's atmosphere, the air begins to roar around our capsule, flames licking the heat shield. The sky goes from black to glowing orange to blue. Parachutes bloom to ease us down, and with a gentle splash or thud, we land. We open the hatch, breathe the thick, sweet air of home, and step onto solid ground. Feel the gravity pulling you back, the weight of your body settling into Earth's familiar embrace. Hear the rush of wind in the trees, the chirp of crickets, or the distant rumble of human activity. After the vast loneliness of space, even the hum of a single mosquito is a comfort, a sign that life is here, abundant and close. Standing on Earth now, reflect on all that we've seen. The cosmos is unimaginably vast and beautiful, yet here you are, a child of that cosmos, standing on a speck of dust that is nonetheless your precious home. You have seen that space is not just an empty void, but a living, dynamic expanse that connects everything. You have learned that every element of your body was forged in stars long ago, and that you carry within you the history of the universe. You have felt how small you are in the face of the infinite, and yet how extraordinary it is that you know this, that the infinite has given rise to beings who can contemplate it. Your perspective is forever changed. The sky above, once just an enigmatic dome of lights, is now understood as a deep ocean that you can navigate. When you gaze up at night, you will no longer simply see twinkling points. You will feel the depths behind them. You might think of the billions of galaxies beyond that faint band of the Milky Way, or of the silent orbits of the planets, or of the fragile station circling overhead with human souls aboard. You might recall that even the air around you is part of space, just a denser part, and that as you breathe, you are connected with the stars that produce the oxygen in those breaths. The boundary between Earth and space is really just an arbitrary line where air gives way to vacuum. In truth, you've always been in space, nestled in a thin cocoon of atmosphere on a tiny world that itself is sailing around a star. We are spacefarers from the moment we are born. It's just that some of us now actually go into the void, intentionally. As the day wanes and dusk falls, you stand perhaps outside beneath the sky. One by one, the stars reappear. The air cools, and the sounds of the day fade. Above, the heavens wheel into view. There is the moon, perhaps a slender crescent on this night, and nearby the evening star, which is no star at all but Venus shining bright. There, westward, is Mars with its faint reddish hue, and Jupiter gleaming high, and beyond it, Saturn, if you know where to look. The Milky Way arches overhead, a reminder that you reside in a galaxy among uncountable others. With the unaided eye, you see maybe a few thousand stars, a tiny sample of our one galaxy's hundreds of billions. Yet even this modest night sky can fill one with wonder. In the quiet, you find that the journey we took in imagination has left a mark on you. You feel both small and great. Small because you see how vast everything is and how our concerns compare to the scale of the universe. Great because you realize you are a part of this universe, made of its noble material and capable of comprehending astonishing truths about it. The cosmos is not cold to you now. It is almost embracing. The silence up there is no longer emptiness, but a gentle, eternal calm that beckons contemplation. Perhaps you close your eyes and listen, not with ears, but with your mind's heightened awareness. You might sense in that darkness a faint presence, the presence of space itself, not as a void, but as a kind of subtle being that has enfolded you all your life. When you were in your mother's womb, space was there between and within cells. When you stand in a room, space is the medium through which you move. When you wave your hand through the air, you are moving through space, and the air, which itself is largely space between molecules. Space is so ever-present we usually ignore it, but it is a constant companion. Now, having traveled so far in our thoughts, you recognize it. The same space that stretches between galaxies also resides here, between the leaves of a tree, between the electrons in the atoms of that leaf. I, space, am here with you, as I have always been. I am the silent partner to all that exists. In the flutter of a butterfly's wing, I am there, providing the stage for motion. In the gap of a heartbeat, I am there, the pause that holds meaning. I was there in the first loving look between a parent and newborn child, the space bridging two souls. I am there in the synapses of your brain when you have a new idea or recall a distant memory. Without me, nothing could happen. With me, there is room for everything to happen. So, whenever you feel alone or small beneath the stars, remember what you have learned on this journey. You are not isolated. You are connected to the very ends of the universe. The space that separates you from the stars also joins you to them. The light that travels through space brings each of us into contact with distant suns. We share the same cosmic fabric with all of existence. In a way, we are all one universe, one existence, just different parts of the same whole. Look up at the stars again. Their light is steady, twinkling only because of your atmosphere. Those stars are nuclear furnaces billions of miles away, yet their light tickles the cells in your eyes. You are literally touching starlight, feeling the energy of another part of the cosmos across unimaginable distance. In that sense, the universe reaches out to you as you reach out to it. For those stars, you are part of their environment, the observer completing the story of their emitted photons. We and the cosmos are linked in an endless feedback. We observe it, and our observations give it meaning. It made us, and through us it gains consciousness. Take a moment to let the enormity of it all wash over you. The age of the universe, nearly 14 billion years. The number of stars in just the observable part, around 100 billion times, 100 billion. The microscopic intricacy that allows cells to live and replicate. The fact that the atoms in your body have existed since the beginning of time, cycling through stars and dust clouds and eventually into you. And that they will one day return to the cosmos, perhaps to become parts of new stars or new life forms. We are threads in the grand tapestry of space and time, momentarily coalesced into thinking flesh. With this awareness comes a sense of peace. The troubles of daily life, though still important on their own scale, shrink a bit in the face of cosmic perspective. The feud with a neighbor, the deadline at work, even broader anxieties of society, all these are like brief gusts of wind compared to the slow, stately turning of galaxies. This perspective isn't meant to diminish our humanity, but to enrich it. We have, after all, minds that can hold the entire universe in metaphor, even as we navigate our personal lives. The challenge and the wonder is to live meaningfully in both dimensions, to care for our tiny world while never forgetting the backdrop of eternity against which our lives unfold. I, space, have whispered to you through the ages, in myths about the constellations, in the mathematical laws that describe orbits, in dreams of flight, and the subtle hints of your intuition. For a long time, you did not understand me. You feared the dark or filled it with imaginary figures. But gradually, you learned my language. You sent up rockets that fell back, then rockets that reached orbit. You learned, and I watched each attempt quietly. And now here we are, having a direct conversation of sorts, after so many epochs of distant yearning. I speak to you now more clearly, inviting you onward, inviting you into my depths to explore, to experience, to learn. Come not as conquerors, but as curious children of the cosmos, eager to discover and to grow. There is room enough for all your dreams out here, and lessons enough for millennia. Each step you take away from your homeworld can unite you more deeply with each other. For in the face of my vastness, what matters but your common humanity and the fragile life you share? I beckon you to venture forth with humility and wonder, to become explorers and perhaps one day, guardians of the universe, carrying the flame of consciousness into realms still shrouded in night. As you accept this invitation, do so with reverence. The universe is yours to explore, but not to recklessly exploit. It is there to inspire and to enlighten. The very effort of reaching into space has already given you technologies and perspectives that benefit you. It has made nations collaborate and has drawn the attention of generations of young people to science, engineering, and the sheer grandeur of nature. Think of what lies ahead if this continues. Your descendants might look back at Earth from Mars or another moon and call it the old country. They might speak of Earth the way emigrants speak of their ancestral home. They might carry forward Earth's cultures, evolving in new environments, and Earth itself might be all the better for it, cherished from afar and understood more deeply when seen as part of a larger context. Now the hour is late, and the stars gaze down calmly as they have for ages. The faint band of the Milky Way bridges the sky, and one can imagine it is the bridge from our knowledge to our ignorance, from what we know to the mystery beyond. But it is a beautiful mystery, one that invites rather than forbids. You find yourself breathing slowly, matching the natural rhythm of your body to the immense stillness around you. In a sense, you are listening to the cosmos breathe. Each slow inhalation you take could be thought of as drawing in the universe's presence, filling your lungs with air that has, in one way or another, circulated through forests, through oceans, and ultimately was made from elements forged in stars. Each exhalation is like giving a little of yourself back to the world, a tiny exchange with the plants that will take that air and use it. It is a silent communion with nature at the most fundamental level. We began in silence and darkness. Let us end there too, but with a deeper understanding. The darkness now is rich with points of light and with meaning we've discovered. The silence is full of latent sound, the music of the spheres, the unheard vibrations of gravitational waves, the faint hum of the cosmic microwave background, all the subtle voices of the universe that we have learned to detect or interpret. The space that once seemed like nothingness now overflows with connections between atoms, between stars, between people and the universe. As you prepare to return to the ordinary flow of your life, take this cosmic perspective with you as a constant companion. In a very real way, you carry the universe inside you, in your atoms and in your awareness. When difficulties arise, recall the patience of the stars and the resilience of galaxies that survive collisions. When anger or division surfaces among humans, recall the sight of Earth as a single, borderless orb and the lesson that, to the universe, we are one. When you feel lonely, remember that you are literally made of star stuff and connected by invisible threads of gravity and quantum fields to everything around you. When you feel insignificant, recall that you are the universe made conscious, a rare and precious state. It's time now. Open your eyes to the night, or if they're open, truly see what's around you. There is the gentle outline of your own hand, made of countless cells, each a microcosm of space and matter. There is the ground beneath, solid from the structure space allows matter to take. There is the dome of sky above, beyond which lies the infinite. Take comfort in the fact that while you inhabit a tiny part of the cosmos, the whole cosmos inhabits you as well. Our journey through space, both the physical travels of our probes and people, And the imaginative travel we undertook just now is one of the greatest adventures imaginable. And it has really just begun. You, or certainly those who come after you, will have so many more wondrous experiences. Walking on Mars, skimming the rings of Saturn in a spacecraft, perhaps standing on the rim of a crater on Mercury, watching the sun loom huge and quick across the sky, or floating in the cloud tops of Venus in a cool layer where a habitat could buoy, or cruising the oceans of Europa beneath an ice ceiling lit by Jupiter's glow. The possibilities extend as far as our courage and creativity allow. The universe will patiently wait for us to arrive. There is no rush, yet there is all the urgency of realizing that life is precious and to be lived fully. Lift your gaze one more time to the myriad stars. Among them may be other eyes looking back or awaiting the chance to be born. Feel the embrace of space around you, not as something cold and foreign, but as a natural element in which we swim. In a very true way, we all live within space, the way fish live within the sea. Earth is our ship, our ark, carrying us through the currents of the Milky Way. We are all voyagers, sharing this vessel, and the stars are our destination. The cosmos breathes, though its breath is the slow turning of epochs and the expansion of space. Inhale and feel that you are part of that breath. Exhale and feel that you give yourself back to that whole. The boundary between you and the universe is, at its most fundamental level, an illusion. The atoms that were once in distant stars are now in your body, and the atoms that are in you will someday return to interstellar space. We are threads in a single cosmic tapestry, each contributing our color to the grand design. And so, our journey, this meditative trek across the stars, comes to a close, not with an end, but with a new beginning, your beginning, armed with cosmic perspective as you go back to the rhythms of your life. Carry this calm, this reverence with you. Remember the stillness of the interstellar void when life becomes noisy. Remember the steadfastness of the stars when you need guidance. Remember the unity of that pale blue dot when petty differences threaten harmony. In doing so, you align your heartbeat with the gentle heartbeat of the universe. Listen closely, one final time, to the silence around you. Within it, if you truly open yourself, you may sense a faint, slow rhythm, the heartbeat of eternity, the breathing of the cosmos. It has been there all along, and it will continue long after we are gone. But for a brief moment, through our voyage of understanding, we synchronized with it. It is in you now, that cosmic breath, and you are in it, forever a part of the universe. And in ways both literal and poetic, the universe becomes conscious of itself. In that knowledge, find peace. In that connection, find meaning. And as you turn to face tomorrow, go forth with wonder and reverence, for you carry within you the voice of the stars and the story of space, the story of us all, unfolding still.